Good evening, everybody. Welcome to Death Stream number 20. Let me know if the audio is working, because I've been tweaking the settings a little bit again. So fingers crossed that I didn't mess them up. We shall soon see. Okay. So, not much to tell this week. Been a busy week for me. So, haven't actually been doing a whole lot of hobby work, unfortunately. Have been trying out the new Apex Legends Season 7. That was a lot of fun to play. Don't know how many of you guys play online games. But, yeah, I'm a big fan of Apex. So, had some fun there. What else? Actually, come to think of it, can I really quickly find that? I might be able to find that really quickly. What's this? No, not Snoop Dogg. I don't want Snoop Dogg. Web Pixar. Let's see if it actually finds this. No. That's Unity Web XR. Someone made some VR games. Okay, hold on. That's just because I don't think. Web XR. There we go, Mr. Snowpex Games. Almost had you in the Snowpex now. And pause that. So I wanted to give a hey Rodzilla, hey Jonathan. Very good. Hey David. Good morning. I just wanted to give a quick shout out to Snowpeck, who has been hanging out on the Discord server. And unfortunately, I haven't had any time to really try out the stuff that he's been building. But he has been bringing Godot VR to web. And it's really interesting to follow his progress. Well, the video that I just found here, if you Google for it, is already his progress report for. I'm not going to play it here, obviously, because we have other things to do tonight. But, you know, go and check that out after the stream yourself or when you have some time. It's really cool what he does. So it basically allows you to run Godot, well, the web version in Godot, of Godot, I should say, but run it in VR. So you can make a VR game in Godot and just publish it on the web, which is pretty damn cool. Yeah, that's really all I wanted to say about that. So yeah, go check out his channel. Go check out the project that he's working on. It is really, really, really cool. So I just want to give a shout out to him because that's some really cool stuff that's going on there. We're back on our space game. Now, I've not done anything in the last 2 weeks on this, unfortunately. My schedule has been pretty full at work. No, not morning for me. It is 9 p.m. for me right now. So, always nice and late here in Australia. So, yeah. We left off with working on the characters last time that we were building on our space game, and we were working on our test scene, or our starting scene. So I'll load that up just for fun, just to sort of remind everybody where we are. So with our little blocky stand-in scenes that we were doing here, I was playing around with sizes, so my little bedroom slash quarters, whatever you want to call them, for our player is now a lot smaller. It's actually smaller or almost the size of our lift. So I definitely found out when I was playing around with the models that I oversized a lot of things. That is really the one of the reasons why we're doing it this way, is to find out those sort of things early before we fill everything up with assets. But I really want to start finding time to actually start building this out. But yeah, life has a funny way of throwing roadblocks in front of you when life gets busy, when work sort of gets the primary attention. For that reason, also, I want to leave that alone for tonight. I want to go back to our actual flight environment. So we're going to go back to our little test scene. I'm going to open that one up. Thanks for the sub, David. So we're going to do a few more things here, and I'm actually thinking about revisiting our little asteroid field. So I'm going to close you off. As a result, also, I want to... Is that in here? No, it's probably in our main script. There we go. Oh, why did I change it like that? Because I do want this one to be our actual scene that we start loading with. But I just want to go back to just starting our test scene so that we can start doing stuff there. And I'm going to just run it just to recap where we were. So back onto our little VR headset because it made a change. I finally managed to shooting a rocket in my own ship. That wasn't quite what I had in mind. I made a change in my OpenVR settings. So let's go fly out. So we still have our frame rate issues when we're inside. And when we're outside, we see that we're now only running 75, 85 instead of 90 frames per second. Until I look away. And all of a sudden we're able to hit... Well, if we're lucky, we're able to hit 120 from time to time. Ha! So, the thing that I changed is I updated my OpenVR settings to actually run my index at 120 FPS. Now, especially when the asteroids are in view, we can see that our frame rate drops at this point in time. And a big reason for that is that my computer is probably able to still render this at 90 to 100 frames per second. But OpenVR will start interjecting frames when it finds out that we drop below 120. So it is actually going to immediately go down to a fraction of our 120. So probably indeed around the 85 mark or something like that. And it's going to try and start interjecting frames there and starting to take some performance away from us. Now, whether I will be able to return all the way to 120, I don't know, because we need to have a look at where our bottlenecks lie. But definitely I want to see if our asteroid field has something to do with it. Now, the other thing that I changed, and this was a real surprise for me. And again, I'm not entirely sure how much of an impact it has on what I am doing so far, but it had an incredible impact on MacRacer, which actually did not run very well on my computer. And the reason for that is that I am using a custom build of Godot, and I'm actually running Godot, or I'm building Godot as a full debug build, which means that all the debug symbols are in there, and if I want to debug my code, I can actually, do the proper things. The downside of that is it turns off all the compiler optimizations, and it turns out that actually makes all the CPU bound stuff in the game code a lot slower. And the difference there was between running MacRacer at a comfortable 60 FPS to getting it down to about 7 or 8 FPS on this laptop. And this laptop has a 2060 RTX in there. So that was quite crazy to see that frame drop. Now, there's a lot more going on in MacRacer than there is in my little game here. So I'm not quite sure where that performance drop came from, whether that is because of all the particles that we're using there, or whether that has got something to do with the fact that we suddenly have a lot more enemy players in there, or there's all the buildings around. There's a lot more going on in that game. So also the load on the CPU is a lot higher than in our little space game here. Oh. Hi, Dalton. Nice of you to join. So the first thing that I want to do, just as a test, is I actually want to just hide our asteroids. Now remember, hiding objects does not have an effect on collisions. You have to actually disable collisions to take them out of our physics engine. So when we hide all our asteroids, our collision system mechanism is still working. I just want to see what this does with the frame rate. If the frame rate is not going to be affected much, that means that there is a lot more overhead in our physics. If it suddenly goes all the way up to 120 when we run it right now, we know that our asteroids are a big part of why things are slow. And again, that is one of the things that I want to start working on tonight, if my cables don't get stuck. and seeing if there is more that I can do with that. Now, I obviously have some drift on my joystick that I'm not quite sure why, and there we go. For some reason that wasn't very good. So still in the ship, we had horrible frame rate, but we're running at a completely steady 120 FPS outside of the ship. It's dropping a little when I turn, which is really interesting. I wonder why that is, because we're not really changing much. And without the asteroids, I have no way to orient myself. I think I have already flown away. Oh, there's our thing. So that is kind of interesting that that drops to about 90. It's going up and down. I wonder. Obviously, I do know that my carrier is having quite a bit of impact. Now, the other thing, which is no, it's actually the shadows are behaving as I expect as well. Oh yeah, that was my... Oh, my enemy ship was following us, and he's stuck over here now. Get behind me. Yeah, well, you know, you gotta turn if you want to get behind me, buddy. Yeah, that's funny. Definitely need to improve the AI there. But, you know, that was pretty much a start. But okay, we do know that our asteroids have a big impact. So that is something that I want to look at tonight. The other thing that I want to look at tonight, and maybe that's even where we'll start. I'm just going to turn our asteroids back on for now. So I've long wanted to actually change the way that the asteroid system works and make it more intelligent. But the other thing that I want to do, for that I just need to restart this thing. Yeah, it's really drifting on my stick. I need to figure that one out too. Okay, which one? There we go. So when I select my my enemy, and I fly past him, then I don't have any visual indication of where he is. So I obviously want to have a visual indicator. Because now I need to look at my radar screen to see where my selected target is in order to start locking onto him again. Now, if I keep following him and tracking him with my head, that's all fun and games. But yeah, if he's behind me and I can't track him anymore, then I have no visual guide to know where he is. Now, anyway, cool. So that is also something that I want to work on. Just to have something in my field of view that sort of points to where my where my selected enemy is. So let's have a look at that one first and figure out, okay, what would be a good way to do that? Now, obviously, it'll just be, you know, drawing some sort of arrow shape. So that part of it, you know, having an arrow shape isn't that hard. But yeah, figuring out how to, where to place it so that it's nicely visible, that's going to be an interesting one. Especially when it's behind me, you know, I want to point some direction for me to follow. Let's see where we can start with that. Okie-do. Okay, that's unimportant. Get into my thingy here. All right. Those are all my objects in my test scene. So that is my player. Let's go have a look at you. There we go. All right, we still have our camera set in there. What's the big green one? That was one of our debug things, I think. Probably our target indicator. Do I want to remove that? This one? Nope. That's our radar screen. It's been a little while since I last looked at this, so it's always getting a bit of a feeling back of where we were. Okay, so that's a shield mesh. Oh. That's the outside. Good one. It's not on our standard plane. Where's I got it? Oh, that's my shield mesh. And again, if I hide that, that's only hiding the outside. Actually, if I hide that, I might be able to select them. No, you can't. Because it's not inside of here. I was expecting it to be this guy. But that. Probably this is one of the things where... Or this one is... How is this one doing? Yeah, that's updating us like this. So that one is linked to a fighter. So this is where we can put our arrow logic in, so that everything we have around our selected target is centered on this this logic here. So that's pretty cool. Sorry, I'm a little thirsty. Okay. I have no idea where a big green thing is coming from. Where is that coming? Is that one of our... Oh, that might be it. That's a missile launcher. Those are hard points. No, that's not it either. I have no idea where our big green sphere is coming from. I remembered building that. That was one of our debug objects to see what we're flying at. I wonder if I expected it to actually be... Oh, it is! Look at that. We were just not close enough with it. Okay, cool. So yeah, that's our test object there. Because we were testing our aim last time that we were working on this thing. I'm going to leave that in there. I'm going to hide it so that it doesn't distract us. But eventually I'll need to remove that. Now, the other thing that at some point I need to look at is our collisions and stuff like that. But that's what I do. So, what I want to start with first is have an object positioned in a way that we can see which way we need to go for our target. So when we are looking at our plane, now our target indicator, which is this guy, is actually parented or childed to our plane. So it's going to be in the origin point of our plane. Now we're going to be sitting forward of that, which is something that we need to keep in mind. But basically we want to take our place of our plane and we want to look at the direction that our enemy ship is. And then to some sort of distance in front of us, we want to draw a direction indicator. And then obviously if we're flying like this and our enemy flies here and goes up, that object needs to go, track that. But we want to then stop or keep that within a certain cone. And then if we extend on that cone, if we go above or behind, we want to sort of hold that object there. Hi SSLX, how you doing? Thank you for joining again. So again, we're gonna start building that in our target reticle over here. No, not our target reticle. What am I saying? In our target indicator. So we're gonna start with that object that we want to place. So in this case, I'm not going to place that on our anchor point because I want that to be a fixed distance from our what do you call it? Can't think of the name now. I wanted it to be a fixed distance from where we are. So let's just put a placeholder object for that right now so we can see if we can make this work the way we expect. And which one would be a good shape? I am going to go for prism mesh for now. So there we go. a really big one. And what I actually want to do with this guy... Does this one do that? No, I don't want to do prism match. I want to do a cone. Cylinder match here, because I can put the top radius to 0, turn that into a nice cone. That's what I want to do. Okay. Now the other thing that I need to double check is what's forward for us. That's the blue arrow. So that's that way. So I want to go and move this slightly that way. We're actually going to move that. Let's say that we're going to move that 10 forward. There we go. Perfect. All right. I'm going to want to add a spatial here. There we go. That's now in position of that. That's there. So we're going to call that direction indicator. And then this guy, we're going to rotate so that it points away from us. 90 degrees. There we go. And that's probably going to look like a circle to us right now when we look directly at it, because it's always going to be sort of in our view. But we'll figure that out eventually. We might do some sort of rotation for that. We'll see. I don't know yet. I just want to give it a start. What do I want to do with materials here? Let's just give it a new material. There we go. And no, albedo. Let's go and make this a red color for now. Doesn't really matter. I also want to have this one unshaded, because there's going to be an indicator. It's obviously something that would actually be drawn in our HUD or in our faceplate. Depends on which way you look at it. Now the other thing that I want to do, is going to be no depth. Actually, I'm going to make this transparent, and we're going to make that somewhat transparent so that it doesn't block our view. And again, we might change the shape completely. We need to figure that out once we make this work. All right. Let's just keep it to that for now. We'll probably need to do more with it. The other thing that I need to do, and I need to have a look at the material that we set up here for that. Oh, that's a shader material. Oh. Kill disabled. Depth test. Okay, so that's just a depth test disabled. I'm going to do that here as well. No depth test. Because I made it transparent, it's going to be drawn as one of the last objects. And without the depth test, that's a difficult word to say. We're also going to draw it even if it's behind something, which means that if our enemy is somewhere below us and our indicator looks down, we actually still see it, even though it's outside of our ship and should be blocked by, the hull of our ship. And that's the same that I've done with these other target indicators, just to, because again, it's something that quote unquote in reality would be actually rendered on the HUD within the helmet that you're wearing. Now we're in the future, so we're going to assume that we have the ability to have that stereoscopic in in the virtual or in the environment that the pilot has in his helmet. But it is going to be drawn over reality, and because also if the enemy ship dies below us and we can no longer track it, that obviously doesn't help the pilot. So that is where we're going for here. Now, this also means that if we have a selected target, we need to position that. If we don't have a selected target, then obviously we also need to go and make our direction indicator. I'm going to make the whole spatial node invisible, makes it easier. Now, in this case, we don't care about whether we have a target lock or not, so we're just going to go and add another section over here. Our direction indicator. Boom. I'm going to get rid of that one. So, obviously, we're going to make it visible. But now we also need to make it track. Now, one thing that we can do, which would be potentially a very easy way to do it, is to just take the vector towards our target. Well, we're already working with a rotation here, so That's fine. Okay, so the other thing that's really important here is that our transform that we've calculated here, let's see. So we got an origin point. That becomes an origin point of that guy. Now that's all in global space. So we need that in local space. Okay. What's the best way to do that? Well, let's first convert that into local space. So I need to know where my target is, but not in global space, but local to the position of my ship. And the way we do that is by taking our, so here, target local, and that is going to be our global transform of our node. And we're going to do an inverse translation of the origin point of where our target is. So that's going to take the global position of our target and do an inverse transform so that it becomes the location in local space of our player. Now, what I could already do right now is use that as the position for my mesh instance or my direction indicator if I want to use that. That's a good one actually, because that is now moved. That actually, I want to change that. Yeah, this one needs to go back to 0. Sorry. This one needs to go back to 10. Where are you? No. So I could move that onto that location. That would nicely be where we want, where we are. But we actually want to go and orient or rotate our direction indicator points so that we point towards our enemy. So that's what we're going to be doing there. But we're going to limit it to a certain amount. So we're going to turn it a certain amount to there to line it up with our target. But if the target is further back, then we're just going to stop there. And the same thing with that one. We're going to turn that way up until where our, up until our limits that we're going to accept. Now the question is, how do we calculate it? Good question. All right. CEO of Swag, Boggers. Okay. Hi, Akadine. Yeah, the clocks changed all the way around the world. So I'm not quite sure what the stream time is in the different parts of the world right now, but it has changed. We had the same problem last week because it changed in Europe a week earlier than it changed in America. It changed a month ago here in Australia. So yeah, it's summertime is fun, and well, if you guys will probably be wintertime, So yeah. Anyway, let's think about this. So if I turn this way, okay. Just trying to think about what the best way to do this is. Actually, hold on. Okay, perfect. I'm just trying to figure out or test the order in which the rotations are applied. So we're going to apply the horizontal rotation first, so the rotation around the y-axis. And then we're going to do the rotation in height. What is the best way to figure out how to do that? All right, let's see. Let's just first do the rotation in the horizontal plane, which we're going to do because we now have that guy in local space. Now the nice thing is 2D rotations, we have a nice way of doing that in our vector 2D. So we're going to go and look up our vector 2. There we go. And we actually have an angle 2 here. Cool. What's the difference between angle 2 and angle 2 point? Returns the angle to a given in radians. Returns the angle between the line connecting the 2 points. Oh, okay. No, we need angle 2. So let's go back to here. And therefore, we're going to start with forward. It's going to be vector 2. All right, so where is this guy? This guy is positioned Z is forward, so we're going to take the Z as that. So we're going to do that with the Y. Okay. So I want to do 0 0.0, 1.0, because I'm just doing it in the 2D plane. So it's like, if we go back to this, it's like if we're looking at this from the top view, right? So our origin point is there, and now I have a vector like that, and I'm going to also get a vector to our enemy, and I'm then going to calculate what the angle is between those. All right, so our angle is going to be forward angle 2, vector 2, and we're going to take our target local dot x and our target local dot z, and we're going to go and normalize that. Boom. And that gives us the horizontal rotation to our target. Now I don't know if that goes negative or if we go back to 360. We will see about that. Let's actually see how that behaves, whether it actually does do this. So I'll do the other angle right away as well. Why not? Oh yeah, and of course I need to go and update this, which is kind of important. So search transform. I just want to see if I can actually set that angle real easily. And I can do that with a new transform. Perfect. So let's go and calculate our x transform. So that's going to become angle y. All right. Now we want to do the same thing for angle x. That was x, I think, that we did. Okay. I think yeah, that's what I'm doing wrong here. Because we now need to know what our new forward vector is by rotating that. And let's go and take this one. I'm going to call that target horizontal direction. There we go. I'm going to store that. I'm actually also going to make that a bit shorter, because I don't like these long names. All right, so that's our target horizontal direction. Very good. And then our target vertical direction. That's actually going to be... Yeah, I'm going to move that normalized, by the way, because I only need this normalized. In this case, I want to do target horizontal direction, length, and then target local dot y. I think that gives my angle that I need. And then this one is going to be oh, and that's why I do need to have that normalized one. Okay. So that actually means that I can normalize that one now. Like this. Cool. And I don't need to normalize that anymore over here. I'm going to put that one over there. And I'm going to put that one over there. Okay. So the first angle is easy because I have our direction that my ship would be pointing to. And it's, because we're looking forward. And then we're getting our angle horizontally. So from here, I need to make sure that's right in the camera. Actually, it's better to do that here, I think. So if our targets, let's actually add in an extra little thing here. Just so I can visualize stuff. Let's do a cube mesh. That's great. All right. So I'm just going to move that over here. Let's move that over here. So our ship is here. So I'm first starting in 2D space. So I'm looking from top down. So I'm ignoring the Y. I'm using my X and Z coordinates. And I'm getting my vector to this guy. Right? That's the target horizontal direction. And then I'm looking, my forward direction is just, 1 forward in the Z. And now I'm calculating the angle between those two vectors, because that is how much I want this guy to rotate. But now, the next step is I want to rotate horizontally. Now, the problem that I have here is that I actually want to rotate within the plane that is given by that horizontal direction. And that is why for that second angle calculation, I am using that vector, but normalized, to get my horizontal direction that I am facing in. But if this guy is also somewhere up, the second vector that I'm getting is within that same plane. That's why I'm taking that length. Within that same plane, I want to get the vector over there. And that gives me the angle within that rotation plane that that guy is at. That's what I'm trying to do there. So with those two angles, in theory, I should be able to say direction indicator dot transform. Remember, we're doing everything in local space here. And now I can create a new transform. And then I want to use my angle X and my angle Y. Don't have an angle Z. And we have a 0 transform there. All right. Let me just zoom in. Why is it saying it doesn't know that one? Transform. Oh, that is from, okay, so that's not based on rotations. Lovely. That's an axis rotation. All right, so is that something that we can do on our basis? No, I want my basis thing. Okay. Once again, vectors. No, I want it from rotations. Okay. Now there is another way to do this. Spatial. because that does have my rotation here. Okay. That reminds me, by the way, our angle 2 in radians. Perfect. So we can actually use that one much better. This rotation as a vector with the 3 angles. That's what I need to do. All right. So that's going to become a vector 3. I'll take this guy out. And instead of transform, we're going to do rotation here. And in theory, that should give us the rotation that we need. So we're not constraining it right now. We're letting any angle go. So let's go and see if our indicator is working, but it will not be stopped when it gets out of bounds. So let's go and have a look. Whoa, shield is rolling the thing again. There we go. All right. Well, it's not working because we can't see our thing. Is it somewhere else in view? It's way over there. Okay, that's interesting. So, what have we been doing wrong? Where is our enemy ship? I'm actually thinking that... that guy is over there. Oh. Okay, I think we're rotating. Yeah. Okay. So the first thing that I'm going to do is I'm actually going to ignore our X angle. And I'm going to invert that guy. Let's see if that works. Let's fix one angle at a time and make sure that works. Okay. That is... well, again, it's not in the position... okay, that's still working. Cool. It's too big, by the way. I need to move it forward more. But the idea is working. Showing me the horizontal position. So, let's go and see if changing the Y or the X in there, if that now also works, angle X, or if we do something wrong there as well. I'm going to assume that I don't need to negate that one, but I might have to. My cable management needs to be sorted out one of these days. So we're going to do that. And am I going to make it smaller, or am I just going to move it more forward? I think I'm going to move it more forward. Okay. That's because I got this guy there. Let's do that 20 forward. There we go. Boom. Doesn't really matter how much forward it is. All right. Okay. So this is really interesting. Oh. Okay. That is very strange. Okay. Okay. Boom. If I rotate this 20 degrees, boom, and now this one 10. 20. Okay. That part of it is working. So we're not calculating this direction properly. Right. So I've already normalized our horizontal there. That's the direction towards our enemy in that space, and then the vertical is that is why. That is what I'm thinking wrong. I don't actually care about this. This is also from forward. Is it? I think. Thank you. And then I just need that. That's why. Which means that I don't care about this line anymore because I'm only using the one space. So I can just do that over here. And I can take that out. There we go. All right. I think that was my... Whoops. What did I do there? Oh. All right. I think I nullified one of the angles as a result. Let's see if that works. Yeah, we need to fix my stick drift. Okay. Okay, it's in the opposite direction, but other than that, we're doing the right thing now. Okay. So the thing that I did wrong here was I was overthinking the vector that I need to do the angle with. It kind of made sense if I did it in 3D space, but we're doing this in 2D space. So the Y angle is easy. I have a forward-facing vector, and I want to get the angle between the forward-facing direction towards my target. But for the vertical, I need to... I've already corrected my vertical to just have the horizontal length in there, and therefore I get a vector that will be shorter the higher the guy is, and then behind it, it will, go that way. But now I'm taking the angle with the vector on the x. Remember, we're doing this as a in a 2D space. So we're basically, when we're looking at this, I have made it so that I am now in my left view, so I need that vector 1 over there. I now have my vector pointing towards my enemy, and I need to take the angle between those two. So a bit of a trick there. But again, these two angles are reversed. All right. So now we want to go and we want to limit how far that goes. Well, before we do that, can we... Yeah, I'm going to do that over here. Yeah, can I do that like that? No, I'll print it. I'll print it to the log for now. This will slow us down, but I just want to see whether the angle becomes negative or whether we're going to the 360 degrees side. STR angle X. STR angle Y. There we go. Actually, let's put that in front of it. It's a direction indicator so that I know which way I need to fly once the enemy is behind me or out of sight. And we're going to limit how far that reticle goes, depending on, whether it's in our peripheral vision. And we're going to make sure that if it's towards the center, if we can actually see our enemy, then obviously we don't need to see our indicator, and we're going to fade it out. All right. But let's first see whether this works. This is going to fill up our... There we go. So that is now working pretty well. And of course, because it's rotating from behind me, it's not exactly in front of that, but that's okay. All right, there we go. Boom. Okay. But the idea is working. All right. So now I have to see what does it do here. So we are getting both negative and positive values there. My cable keeps getting snagged onto my my chair, which is a bit of annoying. Now the other thing is this is in radians, so that's something to keep in mind. Ooh, wrong language bands. So let's go and create a little constant for that, or a little value. Export. Floats our max angle. Let's assume 50 degrees. On ready var next angle radians is angle deg to rad max angle. There we go. Perfect. So what we're going to do here is we're going to say if angle x bigger than that, then angle x becomes that. Else if angle x smaller than that, angle x becomes that. Actually, angle x is clamp. X. This does exactly the same thing, but it's easier to read. And then obviously we do the same thing with our y value. So we should now see that our angle does not extend beyond our field of view. Hopefully. There, we're pointing to another target there. Here we go. So now, okay, that is maybe a little bit too far out of sight. Oh. But does allow us to more easily, actually I don't mind that too much. That does make it much easier to track where our enemy is. All right. All right, that's working. All right. Okay. Let's give that guy a name, and I'm actually going to make that point or look at our target. I think that might be a nice thing to add in. So our indicator look at I'm going to go and use that guy again. Maybe I should store that somewhere so that it doesn't have to keep accessing it. And then from our global transform, we're going to use our Y. Let's see how that works. Now, I don't know if our cone is oriented the right way for that. We might actually need to add in okay. That is definitely now not rotated the right way anymore. But that's because we're overruling our 90-degree rotation. It's kind of funny. So I think we need to add one more helper in there. So I'm gonna make that. So let's actually go and move that in there first. Later. Mesh. Let's see if that does what I hope it does. I'm glad you guys like this. Alrighty. Oh, I'm inside of our plane. That's something that I still need to do as well. Okay. Screwed that up for sure. And the reason I screwed that up is because this guy isn't 10 out anymore. And that guy needs to go back to being centered on that. Okay. Start it again. Oh, get that problem again. Ah! That happens because my shield is actually interacting with my spaceship. Oops, I didn't mean to fire my thing. Alright. Alright, so it is now nicely facing our enemy. But oh. It's actually facing it the wrong way around, but that's okay. Okay. It's definitely close to what I am going for. Because again, I actually don't want this to be shown when we still have our target in view. Now, the first thing that I need to do is I'm actually going to rotate minus 90. I think that'll rotate it the right way around with that look at. So it's going to be a combination of those two. Now, the second thing that I want to do is I want to get a fade out going based on a minimum angle. So I'm going to say a minimum angle here. Let's make that 35. So within that 35-degree cone, I want this thing to be invisible. All right. So, there we go. So obviously I want to do the same thing here and say I want our values to be in degrees, easier to set, but inside of our logic, I want them in radians. All right. Cool. So what we're going to do here is if absolute angle X is smaller than that, and absolute angle Y is smaller than that. Okay, boom. Boom. In this case, we're going to make the whole thing invisible because it's not usable at that point in time. But if we are within that 35 or larger than that 35 degrees and it's visible, we're going to fade it in up until the 50. So for that, we're going to go and have a look at our material here. We're going to look at our color and we're going to actually modulate our target's color. Okay. So we're going to go and create a base color here. So that's the color of our target rectangle. Hold on, I need to get something to drink. Actually, before we add that in, let's go and test if this actually works. So now we should see that at 35 degrees, it should just suddenly pop into existence. Let's see if that works. That's the wrong one. But that is pointing the right way. That's pretty cool. Okay, so we're not seeing it right now because it is, there you go, and suddenly it's visible. Because again, if we are seeing our enemy pretty good, there's no real point in having that. And then it comes into view. And when it's in our peripheral vision, it's nice that it rotates the right way because it gives us a bit of a pointer out. Again, that shape is not final. I just needed to have a shape. But we're going to need a color for this. So let's go and duplicate. No, actually, I don't want to duplicate that because that's going to give me some problems. Indicator color. Or I'm going to make that bright red, and I'm going to give that a maximum. No, we don't need to set get, so that's just going to be a color that we're going to use. There we go. All right. So, I actually want to have that as a onReady var indicator material is going to be that whole thing gets surface material 0. There we go. So that gives us our material. And that way we can change that directly. Alrighty. So here we're going to say albedo color. Nice that it knows which type we're getting. Oh, I'm very thirsty. So we're going to go set a color, and in this case, no, indicator color, .r. So our RGB, obviously, we're going to use as it is. But then our alpha, we're going to modulate. Oops. All right. So, how are we going to do that? I call that modulates, and we're going to do a var modulates. All right. So we've already clamped our angle, so we know that that's not going to be bigger than 50. We've already checked whether we're on the minimum end of that. Although one of them could be, so that's okay. So we're going to do ABS angle X minus min angle rad. Okay, I'm going to clamp that. I actually don't care about the upper one. Okay. I'm going to go add our Y. So this is going to give us a 0 value if it's at or below the minimum angle, and a maximum value of 2 times the difference between min and max. So we can make that a value between 0 and 1, which is what we want in this case, by taking our max angle rad, taking away our minimum angle rad, and then multiplying that by 2. That should give us a value of 0 when our indicator is right on the cups of becoming visible, and it should become more once it's, or all the way to 1 once it's on that outer edge. Let's have a look if that indeed works. We shall see. And maybe I need to make that a little bit more aggressive. We'll see. Okay. All right. So yeah, there it comes in. Ooh, boink. I didn't want to crash into you, buddy. That just moved. That's the downside. If it's... There you go. I think 50, by the way, is too much, and I think 35 is also too much. So we're going to make them... Oh, hold on a sec, because I am looking way the wrong way. Well, you know. Hi. Well, that's what I meant by not doing the depth tests. We can actually see through our floor. It becomes a lot easier to find where our target is. Ding, 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 ding. That shield effect remains pretty cool. Alright, we took one out. Cool. Where's the next guy? Over there. Cool. Still need to have better aiming rectangles, but yeah. Oop. That wasn't quite what I had in mind. Let's see if we can get a missile onto him. No, missiles still don't work very well. Aye. Oh, he's stuck on me. And that was really loud. Alright. Alright, that's my little test guy. Okay. Oh. Oh, that happened before. Our enemy gets stuck on our ship. I'm not quite sure why that's happening, but makes it easy to kill him. And he's gone. Oh, and I hit the ship too. What about that? Alright, where's my last guy? He's out of range. Dang. Yep. That's kind of interesting. I wonder why that guy gets stuck on the ship every time. It's kind of funny. Alright. But we have the logic for our rectangle pretty much working. I am thinking about making that a bit smaller. Let's make that 30. I'm making that 45. That might still be too much. I don't know. I think it's going to be important to have those values affected by whether we are playing this in VR or not. That's going to be another thing at some point. But at this point in time, I am more than happy about that. So, obviously, I think we should have a different mesh than our little cone that we've got here. But I think for now, that does as good a job as anything. So, I'm kind of happy with what that does. Thinking maybe I'm going to squeeze this thing. But not on that axis. Okay. That's also not the one that I'm after. There we go. Maybe a bit more. There we go. I really want to have a cutout of that so that it becomes like an arrow. But that's something that I would have to model outside of Godot. I just want to see if that gives it a bit of a shape. So what I want to do, still need to work on that. All right. not sure about that. Well, it's definitely something to figure out a bit more at some point. I need to figure out what sort of shape I want this to be in. And maybe at some point even overreact on the orientation on that, so that even if it's pointing directly at the enemy and it's we're therefore just looking at the back of it, that we still sort of see a shape to it. But I think that's also, like I said, that's probably a matter of I wonder. Let's have some fun. I'm gonna bring this back to 1. Yeah. But now I'm going to. Well, that's a little bit crazy as well for this sort of shape. It's a bit overhead. That's maybe a little bit too little. That's good enough for me. Bottom radius, I actually want to make smaller now. There we go. Okay. There is a reason to my madness here. Now, because I am duplicating this one, they both share the same material. As long as I keep that one calling mesh, it'll be happy. But what I want to do right now is I want to rotate that by a set number of degrees. I want to have a top view here so that I can nicely align it. Maybe it should be a lot less than that. Again, I'm just trying this out. I don't know. This might be completely ugly. I don't know. We will see. But I just want to create a bit of a hollow shape to it. I'm wondering if... No, that's too little. Maybe 10. Okay, that actually also means... So that's actually a nice amount. And we take away that. There we go. No idea. Let's see how that looks in game. Again, right now it's just giving a little bit of experimentation because I want to create a bit more of a definition of the shape of this. All right. There we go. Let's now move there. That's still something that jump. I know why that's happening, but I'm not quite sure what we could do about that. And again, because it is that 50-degree angle is probably slightly too much out of shape, out of view. It's maybe a bit too jarring. So yeah, let's go make those angles a lot less and make it much more in our view as a result. Yeah, in principle, I like this. I need to play around more with different shapes. And again, I think the best way to do that is actually create a shape in a modeler, a bit of modeler software, and do something with that. I'm going to do a little bit crazy here. I'm going to decrease it by quite a lot and see if that makes it easier to track when it gets out of view like that. Because again, now here we can see that goes straight in my peripheral vision because the target that I select is actually behind me. There we go, it becomes visible there. But 15 degrees seems to be... I think I need to take the highest of the two. Yeah, I think so. I think I'm going to do that. Okay. So let's start with that first. So instead of clamp, I'm actually going to just do max. Does that work? So this is just going to be boom. Because I know one of those is going to be bigger than 35. And then I just max minus minimum. There we go. And I think I'm actually going to make my minimum angle a lot smaller yet. All right, let's see what that does. And I'm even wondering if that maximum number should go down, but we'll see. So that's firmly over there because for some reason I've got something at the back of me. There we go. Yeah. The thing is, if I'm looking here, I can't see where that is. That's why I'm thinking that at 10... Because again, it's the angle from the front of the ship, not from the direction that I'm looking at. Just surprised at how quickly that disappears. So I actually don't even want them to be... I think I'm going to want this one to be 20, and this one maybe even to be 5. Let's have a look. I'm surprised by going that low for getting a proper effect. All right. There we go. Again, that's just over there. There's still too much out of my peripheral vision. Because, you know, it hovers over there. I need to look out of my front view to see it. However, it stays visible for quite a bit longer. And I'm surprised. That's only 5 degrees of vision. I am so surprised by that. There we go. Well, it does work. I think, you know, in VR, this works really good because I'm tracking my enemy. So I'm going to have that visible for quite some time until I'm actually seeing my enemy again. That is really funny. There we go. Yeah. Yeah, I'm surprised by those angles. You know, we could probably even go down to something like this. I was starting to wonder. Okay, we keep changing these angles and they actually don't do anything because yeah. Okay, so all right. Let's go and reset because obviously we were looking at the same things and I was wondering, like, you know, didn't seem to do that much. Boom, boom, boom. Okay. I don't think we reset one of the angles, but we'll see what it does. Because really, this one was really somewhat in the same position. Okay. So now becomes visible over there. That's because now I've got 15 and 20 because I forgot to press save. I think 15 should be my upper limit. I'm going to do 5 and 15. So obviously I do want to do that over here. 5 and 15, save. And now obviously go and reset those. I really wonder why it keeps overriding those values. Now the other thing, of course, is it remembering the values inside of That still looks like it's similar position. Okay. I wonder if that same problem propagates all the way through to where we're actually using it in our test scene. Yeah, it is. Look at that. This is crazy. That is absolutely crazy. And this is even coming from here. Okay, that is still good. So probably because I've got those open, it's remembering those values. So I'm going to close that, and hopefully that'll help. So we might have much too small angles now because it keeps going back to the angles that we started with. We shall see. All right, now we can see that that one is way too much in view. So yeah, here we go. So yeah, that is definitely way too close. So that was our problem, is that we thought we kept changing them, but we didn't. So I'm going to go back to that 15 and 30. So we're going to go, say, 15 and 30. All right. Oops. Now we need to check. Again, it didn't apply them here. Very nice of it. But I also want to double check. If I go here, and over here, then that's still good. So, okay. So there's a problem if my scene is open, that it doesn't remind those things. Thanks, Ishmael. And good evening to you as well. There we go. All right, so that is definitely within my peripheral vision now, which is what I wanted to create. Perfect. So when does it start disappearing? It starts disappearing around there. That's pretty decent. And it doesn't go further than that. And seeing how far I rotate my head, I think that upper limit is pretty good. I'm wondering if I should lerp the angle at which we're drawing. I think that might be a really good idea. Because I think the change is sometimes too quick. All right, let's do that. All right. So, okay. No, I think we need to go and do that. Mouse angle. There we go. Okay, so now we got our new angles here. Now we're going to do a lerp. Last angle X to angle X on delta. And the same for Y. And then we're going to go copy them. And that also means that if we're here, we obviously want to reset that. Oops. All right. Because else, when we change our selected target, we suddenly get a weird effect. Now, we might need to speed up our lerp. We'll see. Ah, I hit the thing again. Okay. There we go. Oh, we're targeting this guy now. Okay. Alright. Let's see if this doesn't do any weird jumps now. We need to see if what happens when we rotate like this. Here, now we can see that it just jumped to a different location. That's pretty good. Alright. Instead of suddenly disappearing. I like that. Okay. Oh, and I am actually not centered properly again. Whoa! I hit something. Ooh, getting dizzy. There we go. Alright. I got his shield knocked off. That's pretty cool. Whee! Oh yeah. Yeah, I think I'm happy with my my directional thingy. I think this is exactly what helps me find where my enemies are. I think I actually need to even change the upper bound here a bit, because the problem that I have right now is that right now I'm looking over there and my angle thingy is actually all the way at the bottom of my vision. Now, again, if this is a desktop game and not VR, then having that small cone makes sense. But because we're able to rotate our head, that limit is actually too small. So I'm going to go to 40. And again, this is something that we would probably, want to deviate from once we have different ships. Because it all depends on, how much visibility do you have in the cockpit? How far do you reckon someone will turn their head? So yeah, that one's there. Okay, cool. All right. So yeah, it's still kind of in a weird position. Huh. Went straight through his, where is he? There. I'm wondering if I should put it a little bit further out. Oh, did he just hit something? Yeah, I think I need to put it slightly further out. Well, I keep getting his shield down, but that's about it. Kind of funny. Okay. Or increase it slightly more. I actually want to put it back to the 50 that we started with. Maybe 45. No, let's do 45. Because again, I was turning my head quite a ways towards the target, and my the rectangle thing sort of got into the bottom of my vision, which doesn't make sense because I'm trying to see where the enemy is and trying to turn towards my enemy. I actually want that target reticle to still be, at the top towards where my enemy is. $0.001 super chat. Why is that? Am I missing something in the chat? Yeah, the LERP. There is a build on LERP. LERP. That one. So you can just use it. Pretty cool. I never actually do anything with the monetization. Let's see. Oh, hi, Anchilla. How are you? Try and see what happens if I press the button. I'd never do anything with the YouTube ad stuff. Okay. We were trying it out on 45 degrees, so I need to do that one more time. So let's try that as last time, and then I want to have a look at what we can do with our asteroids. because I want to have some fun with those. But I want to create a very different system to what we're doing. All right. And again, I only want them to come up when we're really turning. Yeah, that's much better because now it keeps being pretty much in the middle to top of my view when they go out. Pretty cool. Oh, firing on the wingman now. Oh. When these guys explode very close, it's really booming in my ears. Now, it's actually easier to fight those wingmen than to fight the main guy because you basically just turn around each other. We're slightly faster in turning than he is, which makes it slightly easier. But yeah, I still need to very much improve the AI that we've got. Because we're just flying circles around each other. I do like that shield regen effect. That was a pretty cool thing that we built. Put it down. Whoa! And then it flickers back on. Okay. Cool. All right. There we go. There we are. I think we call that a success for our target indicator, for our direction indicator in there. Now, again, one of the cool things about this approach is that everything that has to do with the selected target, visualizing that from the target reticle around our target to our aim reticle. No, our aim reticle I've actually done separately, but the zoom in of our missile lock. And now our direction indicators all combined in a single unit, where I'm using, the location of our selected target to update all those things in one go. So that's nicely contained now, which I'm pretty happy about. I think there could be some optimization done in here because we're reselecting like the origin point a couple of times. So storing some of those in temporary variables might speed some things up. Pretty sure some of this logic can be cleaned up. But in general, I'm pretty happy with how this works. I do think that we need a better mesh to actually visualize our targets or our direction indicator. But, just as a placeholder, just having those two things match up like that, I think that works fine for what we want to do tonight. So that's pretty cool. Yeah, David, that's true. It is, and I think we have a long way to go before this really is, close to what we really want to have in that direction. Now, obviously, right now the AI for the enemies is still pretty simple. Our enemy fighters are just following a path until they come too close to us, and then they start chasing us. But the chase logic is still, very basic. But it's hard because you have the freedom to move in all directions in space. We aren't doing plane mechanics. We're doing somewhat arcadey space mechanics. If you do proper space mechanics, almost. Oh, look at that! I've got some node not found things that I need to figure out. See why that's. I think I removed that at some point. I'll have to figure that one out. But yeah, if you have a proper space mechanics, you're almost playing like asteroids. And we kind of got it here. I have put some drag on to make it a bit more arcadey. But I even had it with squadrons, playing EA squadrons. That sometimes the easiest thing to do is just to throttle down to 0 and then just aim and aim your ship and shoot, which makes you a sitting target. But it's sometimes you're actually better off doing that. And that's going to be a challenge for the AI and building out the AI, because we can mitigate that by making the enemies smarter than they are right now, and maybe implement some attack patterns or something like that, where instead of what I'm doing right now is trying to just fly behind me, is to say I'm actually going to do an attack. I'm here and I'm going to do an attack, and then when I get closer, I'm going to turn away and I'm going to fly some distance away, then turn around and then attack again. And that means that instead of just having this continuous spin around each other and trying to just whoever turns the fastest wins, is when the enemy gets close, he flies off again, turns around and checks again. And we can switch between different behaviors, maybe randomize some, and just at random pick an attack pattern, or make it dependent on how much damage we have. When one thing that I really want to do is that once the shield goes down of an enemy, they flee. They're going to stop attacking unless they have got like a high aggressive level. The moment the shield goes down, they turn and they try and fly away from you until the shield regens, and then they turn around and then they attack again, which means that you can give chase and take them down properly. Right now they just keep attacking, which is actually probably better because it's harder to take them down. But yeah, we want to put some flee mechanic in there as well, where they just flee away from us. But I didn't want to do the AI stuff today. Just looking at what these big circles are. I think those are our detection circles from our different radars. Anyway, I wanted to have a look at our beautiful little asteroids and start looking at what sort of system we can build for these guys to make them a little bit more smarter. And there's actually a couple of things that I want to do. The first thing that I want to do is, right now we've got these big blocks of asteroids with a whole bunch of them in there. So 100 asteroids per multi-mesh. So I wanted to start doing this with pathing. When we look at an asteroid, we're thinking about an asteroid belt. So one of the things that I'm thinking about is to lay a path, which is my asteroid belt path, and then to have some code that generates our multi-meshes along that path and starts filling those up with asteroids. And we just we lay the path, and we have a button that says generate asteroids or update asteroids, and that creates all that. The other thing that I want to do is I want to start looking at an LOD system for our asteroids, so that the ones that are far away are going to be really simple, the ones that are close are going to be more detailed. And there are basically two approaches that I want to try and see which one works best. Now, one is simply to change the mesh that we are displaying in one of our multi-meshes, depending on how far away our multi-mesh is. Now, especially if we start making smaller groups, let's say that every multi-mesh is responsible for drawing 25 asteroids. So instead of having one big multi-mesh with 100 asteroids, we actually break this one up into 4, and we do that. That's a possibility. And then we switch 25 asteroids to a different LOD level all at the same time. So that's one way. The other way that we could do is we could take our levels of LOD for our meshes, and we can add them all together in one big mesh. So we load them all up into Blender, we add them all into one scene, merge them into into the single mesh. And I think we can do that by saving them as a waveform mesh. I'll need to have a look at that. But then using vertex IDs or vertex colors to identify which mesh is at which LOD. So let's say that the furthest LOD is white. The LOD 3 would be green, 2 would be blue, 1 would be red. And what we're basically doing is that when we write a vertex shader, which says if the center of my asteroid is within my LOD1 range, which is red, so it's closest, then I'm going to discard my asteroid or my vertex if that color is not red. And it would do that for every vertex, and therefore that LOD level of the asteroid doesn't get drawn. Now the question there is, it's a balancing act, because we're still doing all our vertex processing, and we're doing actually more vertex processing than if we would just switch the whole multi-mesh. But what actually gets rendered is the correct amount, and I don't know where that balance lies. And I think that really depends on how details your biggest LOD level is. And maybe we even need to combine that and say, well, our biggest LOD level, we switch to the whole thing if our multi-mesh gets close enough. But anything further away from us, we start doing that level of detail, switching in the vertex shader. I don't know. I have no idea where that balance lies. I don't even know if doing the discard is already going to be causing too much. Now, I think there it's kind of okay, because we are already doing clipping on the whole multi-mesh as a whole. Yeah, Elite Dangerous does it really, really well. Although I need to figure out why I can't actually run Elite Dangerous at the moment, because I bought Elite Dangerous when it came out, and I installed it on a laptop that has since crashed and burned. So I wanted to install it the other day, and I can't actually reactivate my account. I don't even know what my account details are anymore. I fear that my account on Elite Dangerous is linked to an email address that I don't even own anymore. So, yeah, gotta figure that one out. See how I can reactivate my Elite Dangerous account. Doesn't need to buy it again. Not quite sure if I'm up for that. Yeah, I've got all the roll and pitch and yaw in there, but I need to tweak the settings and see how, because it's pretty aggressive right now. No, it's not a lot of data, because it's we basically have one asteroid right now. Now, in that case, you probably want to get some more asteroids in, and that's the other thing that I'm not sure about. If we want to have some variation of asteroids, and that's actually probably maybe even a better idea, is that we actually create the variation of asteroids by vertex colors, and do the LOD by switching. All right. Okay. Now, now, it's been a while since I last did this stuff, so I'm sort of thinking in my head, okay, what's the best way to do this? Well, the first best way is to actually hide all these guys again, or maybe even delete them. Do I want to create a separate scene for this? That's a good one. That is a good one. The other thing that I want to do is I actually want to implement our multi-mesh logic as sort of like a simplified BSD tree. That's the other thing that we're going to start looking at. Okay. Let's do some experimentation. We're actually going to create a new scene first. Let's start dealing with that too. Oh, that's weird. Okay, spatial. Did I spell that right? I've got no idea. All right. Where is this stuff again? Asteroids. Okay, so I'm gonna go and save that there again. That's just gonna be helper scene. You know what? I'm gonna close that guy off. It's been our file system. So that's our test scene. I'm gonna go and duplicate you. And now I feel pretty happy to go and delete my asteroids. Bye-bye asteroids. Okay. Boom. Asteroids. Let's go and put our asteroid belt scene in there. Okay. So that guy needs a script so that we can declare some stuff. Very cool. And the first thing that we're going to declare is an export path. The path is that node path. That's it's a node path, I think. Yeah, let me double check something. Testing. Yeah, exactly. Same thing as that. So is car belts. Yeah. Okay. Now, one thing that I want to do here is when you look at this sort of stuff, it's actually a good one. Oh, let's see how far we get with that. So that's going to be null. That's good. Set get set path. Yeah. This is going to be func set belt path. New path. Boom. Belt path is new path. There we go. If belt and is inside tree. Then we're going to go and update our path. Okay. And in this case, obviously, we want to go and reapply it, because the first time that happens, we're not going to run through our logic. And the second time that it runs, it is going to run through the logic. Pretty cool. Okay. Yeah. Okay. So we have a path again. Let's move this guy out a bit. There we go. I'm just gonna make that path a. I'm just gonna do that like that. Why not? Assign path. That's gonna be the path that we're gonna use here. We've got a curve. No, don't click on that. I want to do a top view here. I wish there was an easy way to just create one at the start point. But that's close enough, I guess. Boom. 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 Good enough for me. All right. Boom. Boom. Let's make the paths a little bit bendy. In this case, I don't really think that matters, because we're going to get lost in how our asteroids are anyway. But, you know, might as well. Okay. Obviously, that's going to be a very crazy curve for a an asteroid belt. Asteroid belts aren't that curved, but we're just experimenting, right? Will LOD be built in for Godot 4? Yes, there is talk about implementing a LOD system in Godot 4. Though I don't know what the details are. I know that there's a couple of things that have been discussed. One is having some form of automated, if you load up a high detailed object, that Godot will automatically create the lower detail objects for you and possibly do it in a way like I just discussed on actually applying the LOD levels in the shader. But in a different way than I just did. So I'm just talking about discarding in the vertex shader, which is kind of dumb. But the other option that you can do if you're building it into the engine is if I have an object. Let's say that I've got an object with 10,000 vertices. I'm talking specifically about vertices, not about faces, because the optimization logic works on vertices. And I actually have that optimization logic, for instance, in my ProcMesh library, or a version of it. Now, you can make automatic logic that will take that 10,000 vertex object and then simplify it to 1,000 vertices, and then simplify it to 100 vertices, and then simplify it to 10 vertices. And that's your 4 LOD levels. But in simplifying it, the one that I was using, the technique, I can't remember what it's called, but basically what it does is it will merge faces together and try to discard vertices, which means that if you have your 10,000 vertex object and now you have your simplified 1,000 vertex object, those 1,000 vertices will actually be 1,000 vertices of the original object that you started with. You just have a face list that for your high level object, and now you have a new face list, an index list that uses just 1,000 of those vertices. It's not a complete new object. It is reusing the vertices that you have, but now with a shorter list of indices. And then you go to the 100 indices or vertices level, and you have a index list that renders that one. And then you have the last one, which is simplified. Like say 10 vertices, which will probably be almost a cube. So you have those 4 levels as a result. And all you have, so you got 10,000 vertices, and you have 4 index lists. And depending on how far away the object is, you either do a draw call for your high detail one, or your middle detail one, your low detail one, or your lowest. And you could even go as far as that if you're very close to that level, because again, you're using the same set of vertices, you could do some sort of blending between the higher level and the lower level thing. So that is one of the things that I know has been discussed to see if that is an approach that we could add into Godot. What I personally hope is that we'll have multiple approaches. So when you look at the original approach, which was in Godot 2, I think. I don't have a mesh handy right now. Let's throw in a mesh. The things are still in here, I think. Or did they remove them? Oh, they removed them. Because they don't work anymore, they removed them. What did they do here? LOD, right here. So we have our minimum distance and our maximum distance values here with a hysteresis, which it just means that there's a different point where it goes from one LOD level to another. So the idea here was that, saying again the same version that I just said, we have a 10,000 vertex object, or 1,000 vertex objects, or 100 vertex object. You would actually have 3 meshes, and each with a different distance, and you would just hide one and show the other. I hope that they add that back in because that's the most simple version and for certain geometry the best. Especially if if you have certain larger things. And probably one in the shader, and maybe even some other options. So yeah, in the end, I know that there are discussions about these different approaches and trying to figure out which one is the one that we actually want to have reintroduced into Godot, and we'll see what time will bring. Hey, Michael. Hey, Gabriel. Hey, Disco Nias. Disco. Oh, Jesus, can't even pronounce that. Yeah, I think so. And then one of the last Q&As have probably got mentioned as well. This currently has no effect, yeah. Because again, they wanted to reintroduce it, so it kept going down the priority list, and especially the Godot 2 implementation of LOD, where it's basically working with the min and max and hiding the right mesh or showing the right mesh. You can create that yourself, right? You can just put a script on your object and calculate the distance to the camera and hide it or show it. Now, the problem, and we're going to run into that here as well, and we're going to optimize for that, is if you do that every frame, especially if I'm running at 120 frames per second, then you want to, even with doing it on the basis of a set of multi-meshes, it still means a distance calculation for every 15 asteroids that we're applying. So that's not something you want to do every frame, but also there is no point in doing it every frame. Even if you do it, the LOD checks, every 5 frames, and distribute that time over that period. You're still going to get there. And I think even with something like the LOD switching, on that level is something that's really suitable to run in a thread, because again, you don't care about that your LOD switch is 5 frames too late. You're not going to notice that as a player. You're still hopefully far enough away from that object to not have a visual pop of the LOD change, and whether it's immediate exactly on that distance, or you happen to not notice that you're close enough when you move the meter more forward, who cares? It's. I think for the space game, it's a little bit more difficult because we are traveling at quite higher speeds. But yeah. All right. So we've got a path in here. Did it save the path? Yes, it did. So we're going to be using that path to do something with. So yeah, one of the things that is interesting here, and what CSG path does, for instance, is we can. That reminds me, I want this thing to run in the editor, so we're going to make a tool script. So, we can link up to the signal of whenever the path changes and then update everything that we're doing. And maybe we're going to start there, or we're going to add a button in or something that allows us to do a recalculate or a rebake of the asteroid map. That's something that we need to figure out is the best way. For now, I'm going to assume that we're going to do the immediate approach. So we're going to add a function in here, which is going to be called update belt. And we're going to call, we're going to do a var no, actually, we want to have the belt curve. We actually don't care about our belt path, do we? Yeah, we probably also want to go and store transform here. So actually, I'm going to do this as a curve. Oops. So we're going to go and remember those. I'm just going to reset. Why can't I do a capital T? Curve. There we go. We want to go and make those empty if we don't have those. Oops. That needs to be like this. And in this case, what we're going to be doing is get nodes dot path. Actually, you know what? I'm gonna move that over here. Reset it all. If we have a path, we want to have a belt. Transform is path. Yeah, why not? The thing that I'm wondering about is we probably actually want to. I think I want to store this guy as well. I'm just going to call that node. Okay. And in that case, I actually don't want to store the transform because we're going to have access to that. So let's get rid of that guy. And let's get rid of that guy. Not gonna worry about that at all. Okay. It's not called per curve, really? Wow. Yeah, it's supposed to be called curve. Oh, because that needs to be a curve 3D. That's going to be a lot of fun when we're going to go Dofi 4. We need to rename all those things. Hey, Lord Onan, welcome. Nice that you can call it live for a change. What time is that, actually? 11. We've got about an hour left. Let's see how far we get in an hour's time. Okay. So. Okay. Okay, so we got a curve. All right. Okay, so path, curve. Now, sorry, I'm just thinking a little bit how I need to do this. Because when we change our curve, we can link to a signal. that tells us that the curve has changed. And actually the curve change signal is on the path itself. So whenever our curve changes, we get a curve changed signal. Okay. And actually, I'm thinking that we shouldn't be storing the curve, because I think this is called both when our positions of our curve is changed, or if we change the curve itself. So I actually want to not do this and not do this and not do that, and instead I want to do a belt path dot connects, and then the signal is going to be curve changed on self, and we're going to do, oops, that needs to be a function name. We're going to call update belt when our curve changes. There we go. And obviously we're also going to call update belt here. Now, one of the things that we could do here is check if we have a path node and disconnect. We actually also want to do that when our script gets destroyed. Do we get a signal when our script unloads? Do we care? I don't think we care, because this is only going to be destroyed when the path gets destroyed as well. So I'm actually not too worried about that right now. All right, so here we're going to actually do curve 3D is belts path node dot. Now obviously we're only going to be connected to this if we have a path. Yeah, I think we are going to want to reset it just in case. Curve. If curve. Dots. Alrighty. Yeah, let's just do that just in case. If disconnect. And we can just go and copy these. Now again, if we want to be really perfect about this, we also need to just disconnect when our our thing gets unloaded. But because it only gets unloaded when our scene gets unloaded, and if our scene gets unloaded, also our path gets unloaded, the signals are going to go away anyway. If that was not the case, if that was a situation where our asteroid belt could be removed while our path stays, can't think of a reason why we would be doing that, then obviously we would need to react on that, because else we have our path signals connected to an object that no longer is loaded. But in this case, because of how we're using it, it's never going to change, right? It doesn't make sense. It's not something that we're going to be doing on the fly. This is purely going to be stuff that will run in design mode for us to help, and the first time that we instantiate our scene. So, hi Aaron, I am glad you are finding the videos useful. If you are new to Godot, I can highly recommend channels like Kids Can Code, GDQuest, Heartbeat, PixDev, so many other channels, Game Endeavor's channel. There are a lot of good Godot channels with beginner tutorials where you can learn how to use the engine properly. But you know, you're more than welcome to join here and see what I'm doing. I tend to do somewhat more advanced stuff, but hey, if you can learn from it, then I'm happy. Then things are good. So so one thing that we probably want to do is when we do update belt is do some sort of cleanup. We'll see how that goes. So our first order of business in our test scene, when we have our path set, is that we want to go and create the multi-meshes that we are going to have. Now, in the design mode that we are in right now, we're probably going to take it a little bit easier, or we're going to maybe make them a little bit larger, because we would just want to have an indication of what we're doing and not actually build, a million asteroid, an asteroid belt with a million asteroids in it. That just doesn't make any sense. So we're going to make a difference between whether we're running in the editor and how we're going to apply our values then, and if we're running in the game itself. But we are going to make this in a way that we can completely visualize what's going on here and see things work. Now, one downside of what we're doing, and we kind of ran into this as well when we were doing all the setup for our character, our bone editing and all that sort of jazz, is that every time that we change things here and our script gets reloaded, Godot gets confused because it's not retaining certain things in the toolset. So we're going to be reloading our test scene a few times. Now, the other thing which is really cool about this is the way that the scene system works is if we are adding stuff to our scene in code, which we're going to be doing here, then Godot shouldn't save that along with our scene info. It's kept there purely in memory, unless we specify that that node is now owned by the scene. And then it will actually, that's how the editor works. Whenever the editor adds a node, it doesn't just add a node to the scene tree, it then also makes that scene the owner of that node, which means that when the scene is saved, that node is actually saved as well. But the way that we're going to be doing it, hopefully, and we're going to have to test that, nothing will get saved. We're going to generate it as we load in. That also means that everything that we're going to generate in the editor is purely visual guide stuff. It's going to basically be tossed away. And that's something that I want, because I want to have it simplified in the editor to give us a good idea of what we're doing. Now, in our asteroid belt, we're going to create we're going to create mesh instances along our path in which to put our asteroids in. Now, there's two ways that we can do this. Just start creating them along that path with some sort of logic that places them at a certain distance from each other with maybe a bit of overlap, and then you random generate some asteroids inside of each. Or we could start generating random asteroids and have the asteroids define where we're going to have our bounding boxes. I'm not sure about that one yet. I think we're going to go down the approach of following our path and just creating the bounding boxes as we need them. So let's start with that and see how well we can do that. And again, this may also be a reason that I might fall back on saying, well, you know what? We're actually going to go and save those asteroid objects and not regenerate them, because random generating a large asteroid field takes time in GGScript. That's actually one of the things that GGScript isn't all that good at. But we'll see how well it works. There are good ways to kind of deal with that. We'll see how well it goes. So one of the things that we really want is we want to create another scene. New scene. That'll be a 3D scene. Do I want to have a spatial here, or do we go? You know what? I am going to start with a spatial here. So this is going to be asteroids node. I'm going to call that an asteroid belt node. There we go. And here we're going to create our mesh. Why am I doing it like that? I need to press the other button. Multi-mesh instance. So here we're going to create a multi-mesh instance. And we're not actually going to load anything in there just yet. That's the one that we're going to be populating. Although for now, just to start, just to see what we're going to do, what do I want here? It's a good one. No, we'll do that in code. Okay, so great. Our asteroid belt. Boom. There we go. Things are coming. Now remember, this is the problem that we had before with some of these other ones. Is that we created our multi-mesh instance over here. And they started to become shared among the instances of this this node. And even if we had our beautiful oh, that's in here, our local resource tick box turned on. So we're not going to do that this time. We are going to go and create that in here. So again, this needs to become a tool script so that this works both in the editor and here, because we need them in the editor. This might actually start creating one on the fly. I'm not quite sure. Anyway, multi mesh is let's forget. Yeah, new multi mesh. The resource, I think we can just do that like this, but I could be wrong. Okay, and then that's new. There we go. We're creating a new multi-mesh, and we're obviously going to do multi-mesh instance. The multi-mesh is multi-mesh. There we go. I always forget what the properties of this guy are. Multi-mesh. Okie doke. Now. All right. None is default. Cool. So we need to do transform format, which is this one. Boom. Multi-mesh dot transform format is going to be transform 3D. Does that work? Also, I'm just going to multi-mesh dot transform 3D. Thank you very much. What else? Custom data, we're going to leave 0. Color, we're going to leave 0. Instance count and a visible instance count. That's going to be important. So, multi instance count. Let's say 15. Actually, that's something that I want to make settable. So, you know what? No, let's just leave that at 15 for now. We might make it settable. I'm not sure about that one yet, because whenever you change that, it's going to be recalculated. Let's go and put that next count. Make it a variable at least that we can control that and easily change it. Okay. Visible instance count is going to be 0. So we're going to reserve space for 15 asteroids in this multi-mesh, but we're going to say that we don't have any. And that means that adding some is going to be relatively painless. If you don't do it this way, then it's actually quite a lot of overhead to increase the number of instances that we have here. Now again, we might do this differently. The other thing that I'm thinking about, which might be the thing that that eventually we'll need to do here, is making this an automatic BSD tree, which we might actually get to as well. And that means that once we hit our count, we actually split it in 2, or we create an extra multi-mesh instance, and we divide them by spacing. We basically half them, and we do some of that. Not sure yet. Still thinking about what is the best approach here. Okay. For now, we'll keep it like this. All right. What else do we need to do? We need to have a mesh. Okay. On ready var. Okay, that one I need to find. Assets. That's the ones for union bytes. Okay, we're using asteroid 2. We had the 3 mesh levels. New inherited. Now I can't remember. That was the least one. That was slightly more detailed. And that was the most detailed. Okay. Don't save. Let's load them all 3. 0, 1, 2. Boom. 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 Okay. And we're just going to default this to lots 2. Okay. We're actually going to add one more. Okay. Let's go back to our asteroid belt. Load. Zero, 1, 2. Load it in. I just want to see it. There we go. Oh yeah, we had that automatic rotate in the material. That's fun. Another one. There we go. And move that a bit more like over here. Don't care where to where. We are gonna go and create a cube. Boom. And I'm gonna make that a bit smaller. Boom. And we're gonna load up a material. Oh, that actually needs to be material in here. Load. Well, that looks really funky, but I don't actually care because this is always going to be too far away to actually see this. We just want this to be in general relationship to this. Now, obviously, the rotation speed is the same. So we need to actually go. That's right, because we made the rotation speed based on the position. So I need to position them at the same space because I want to make sure that they're relatively the same size. So let's just go like this. That is roughly what we want. Cool. Sweet. We have a rotating cube that looks like our asteroid. Okay. And we're going to save this. And we're going to go to asteroid 2. And we're going to... Oh, that's a trash. That's not right. Hold on. Oh, that is a trash because this is a resource. Okay, that's fine. So there. Show all files that we have here because I just want to get the name right. So this is going to be asteroid 002 lot 3. Boom. Okay. Goodbye to you lots. Let's get back in here. Let's preload that. Now, the important thing here to note is even though we're going to reuse this scene time and time and again, and we're just going to have all 4 meshes here loaded, because of the way that Godot works, once you load a mesh, it becomes a resource. If you load it into another scene, it reuses that resource. So these all become pointers to the same meshes. We're not going to load these meshes multiple times into memory. All right, so here's a nice little cube. Boom. And we're going to start with our LOD3. And one of the things that I want to do here is that if we are in design mode, we're going to keep using our LOD3 and get boxes as asteroids. And once we get into run mode, we're actually going to run and switch these 3 out. So actually, if I make visible count 1, there we go. Now here we should not see anything because it hasn't created anything. Now probably if I reload this is going to be an interesting test. It actually loads that thing because it's now a tool script. It's going to run through our ready script and it's going to add that in. Now, as long as I don't do anything with it, I don't think that gets saved. That's something that I need to be careful with because obviously I don't want this guy to be saved with that mesh in place. In the end, we'll only be changing the script anyway, so we should be pretty okay there. Now, with our asteroid belt, we're not doing anything just yet here. But here, the same thing applies. Now, in this case, it's going to be pretty neat because as long as I'm in here, my node path is always going to be null. So I'm never going to be running through this info. So that is never going to be assigned. And therefore, the logic is never going to run. I don't have to worry about it suddenly creating a whole bunch of things. So here we're going to get another unready var, and we're going to call that asteroid belt node. And in this case, it's a node of a different meaning than we had before. And here we need to go and get this scene over here. Okay, so I saved that in the wrong place. So let's go and do that. Okay, let's go and close this or else we're going to get in trouble. Move to assets. No. Scenes, misc. Move. Okay. So now our files are together. Yeah, always keep saving. You have no idea how often I've lost code because I forget to run save or press save. Okay, so we got our asteroid belt. We got actually I want to go and close all this, start over again because it's getting a little bit convoluted in there. So that is that. Then we have this guy, very good. And now if I load this, that should still have nothing in there. That's just an empty thing. Okay, cool. I'm going to close that one for now. Is that still? Oh, it's because I got that one. Okay, that's fine. Asteroid belts. So, if our belt is in here, we're going to want to create these belt nodes. All right. Now, there's a couple of ways that we could do this. Oh, yeah, that's the other thing I need to do. No, that's all going to be in here. Now, one thing that I'm thinking about, but I'm wondering if that's not going to be too slow, is that we're going to randomize a position in relationship to our curve. And when we have a random position of a new asteroid, then we're going to create, or we're going to check within a sort of like a bounding box sort of space. What am I thinking? And the thing is, I wonder if that's going to be too slow, because basically the idea is if there isn't an asteroid belt node at that position, we create one. If there is, if there is, we just add it in. It's a good one. Which again does make me question about okay. Let's actually go down that path, but with a difference. Okay. So I just have some things standing right in front of my feet, and I keep kicking my feet on it. Hour on time. Oh, we're getting late. Yeah, because I do want to do this in a way that we're not going to overload ourselves. Okay. So what I'm thinking about right now is we take a path and we give a maximum spacing that we want to use for one asteroid belt node. So we're going to start off with actually quite a large area that our node is going to be covering. And then we're going to random generate a certain number of asteroids within that space. Now again, there's two ways to approach this, and that is one. I'm just wondering if I want to build this automatic BSD tree logic, or if I just want to fill up nodes around the space. Let's actually up the number of asteroids we can see in one node, because I think actually 15 is way too little for what I have in mind. Maybe it's not, but we'll see. And also our collision stuff isn't in here yet. And that's something that I also am very conscious about. That we might get into trouble. Okay. Let me think. What's the best way to create that and break it up? Where's my testing? Where is my testing? Where is my testing? Did I? Oh, okay. I'm gonna turn it on. Turn my heater on. That's not good in summer. All right. Okay. Let's just start simple. Well, Um, no, actually, let's go and say node size. I'm gonna make that 100. Okay. That's fine. That's the space within which we're going to create stuff. And just for testing right now, that means I need to load that thing. Just for testing right now, in here, I'm going to add in a mesh instance. Boom. I'm going to add in a cube. Cube. I'm going to make my cube 100 by 100, 100 by 100. That's the space that we just allocated for that, which is probably way too small. Oh, for 15 things, that's probably a good one. And then I'm going to make the material for this one. No, not a shader material. Spatial material. I'm gonna make it transparent. Color. Nice green. Nice transparent green. Because I just want to see how we're placing those. Okay. So there we go. Sweet. Okay. Okay. 100. So let's get a curve size. Curve dot length. Big length is for length. Boom. Steps is length divided by, what do I call this thing? Node size. There we go. All right. And we want to go floor then, I think. Yeah, I think floor is fine enough for what I had in mind. Okay. Range 0 steps. Okay. Oh, that's range. In range, okay. Mixing up my let's go dist. Here I just want to go and do dist is dist plus node size. Okay, cool. Not that. Bar center. Get. Sequence. I always forget which ones we have here. So that's an array. That's not what I wanted. Interpolate bake. That's what I'm looking for. Is this. There we go. Alrighty. I just want to create a spatial here so that's easy to clean up. There we go. And here, what I want to do is, well, nodes dot get child counts bigger than 0. If we still have children, we're gonna go and do our child is nodes get child 0. Remove child. 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 2, 3. Boom. Sorry, first removal. Boom. Alrighty. And then here we're gonna say no is okay, I'm gonna call it new node. Also make sure that this is set, just in case we have a problem loading that. We're gonna need to create a new instance for this. Perfect. Then we're going to do nodes dot add childs. New node, sorry. And then new nodes dot transform is going to be dot origin is going to be a center point. There we go. Now the other thing that I really want to do here that's never going to call unless we have one. Let's make sure of that. Shouldn't be possible that this is called if we don't have that, but you know, better safe than sorry. There we go. And now one thing that I want to do here is I'm going to say nodes.global transform is belt off node is global. Okay. So we're going to make sure that our node here isn't going to be positioned on our asteroid, but it's going to be positioned actually where our path begins. Because that is going to make sure that our scenes are properly positioned along the path. Look at that. It's already working. Ah! Here are all our beautiful little nodes. And each one has one asteroid inside. How cool is that? Sweet. Cool. Now, I'm quite happy that they have some overlap because this does not need to be precise. I just want to create these guys here. All right. So, and we can see that. Now, in theory, if everything works, that should mean if I move this, it's continuously recreating our path. Now, that's going to become slower and slower as we add more stuff in, right? So, let's see if that 100 is good enough for what we want to do right now. But yeah. So we're gonna want to make our thing wider now. All right. So, how many are we gonna make side by side? And do we also go up and down? That's also a good question. Okay. Export. Bar. Width. Man. Let's say that we do 5. We're going to make it 5 nodes wide. All right. So, Okay. I need to have the next. Actually, let's call it forward. And that's going to be plus node size. I guess we could store that and reuse it, but I'm happy to do it like this. Center. That gives us a forward direction. And side is going to become forward dot normalized dot cross vector 3 dot up. We're going to take the cross product with our up vector, which is going to give us a side vector. Perfect. All right. Now we're going to say center is center minus side times width times 0.5. See if that will work. It should already be funky. It should now. Whoop. Oh, yep. We forgot something. Where are we? Side times width times 0.5 times node size. Okay. Did that work? Or did we just screw it up? Okay. I'm going to reload this just in case that's a problem. Yeah, that was the problem. Okay. Where is our path? Oops. Path. There we go. So we're actually moved somewhat to the right, but that's fine. That should be... okay, that's cool. Asteroid bounce. Boom. Okay. 4 x in range 0, comma width. Okay. Center plus side times node size. Boom. Side. Sorry. Let's see if that worked right away. Nope. It did. All right. Our half isn't working properly, which is interesting. And I think that's because our width is an integer and we need that as a float. So let's make that a little bit smarter. I'm going to call that offset. I'm going to say far offset is this, but I'm going to start with our floating point value. Because if that's the first one, then that should become a floating point value as a result. I think I might even do it like this. Okay. See if I was right with that. And of course, I probably have to reload that. All right. Well, I don't know why we have those gaps in there. That's interesting as well. Hey, Drageo! Hajitspo! Glad you guys could join. Hope you guys are enjoying what we're doing. Just to rule this out. There we go. Okay, need to reload it again. Oh, it's still not on the center. What am I seeing? What am I doing wrong? Hmm. Taking it forward. Do I need to normalize this as well? Might need to. That's the thing. Okay. I'm going to remove this. Okay. So we already see that the first one isn't even positioned on our path. Why is that already forward? Sorry, Louise. I'm horrible at remembering people's names, so tend to call you guys by whatever name you pop up in the stream. Yeah, that's your company name. Makes perfect sense. So the thing is, we're starting on our distance 0. So our center 0 should be exactly where our curve starts. Let's double check if this works. Cube. Okay, do I need to reload that now? Okay, that might just be because it's too small. Yes, it's exactly there, so that's cool. So why is our first set so offset? That's weird. Path is there as well, so that's good. But our first offset should be over there. All right. No, that's going to be deleted if I add that to nodes. We know that's not going to be moving. Oh, because I increased my distance right at the start. I don't want to do that. I want to increase that at the end. There we go. All right, now our first one. Well, it doesn't start in the center because our path doesn't start in the center, but it now starts nicely in the center of our path. That is good. All right. So now let's reintroduce this one. All right. So if we get our path again. So that's still not offset the way that I expected it to. Why not? Scripts. Let's go and print our offsets. Yeah. Ishmir, you're probably going to recognize that one. Here's why we have to reload this friggin'. Where are you? 250, which seems exactly what I want it to be. Because we got 5 times 100 is 500. All right. So starting to get the trick that as long as I make sure that our scene isn't the current selected one, it actually works. Boom. All right. I'm just going to leave this like this and see if it still gives me the right output. Level path. Yeah. So this is obviously going to slow down a lot, and that's why I'm thinking that I don't actually want to do this every update. Look at that. That is pretty cool, actually. Why does it do that? Because obviously, you know, we're creating so many now. Boom, boom, boom. And we're going to go at higher as well. So that's going to be interesting. In which case, you know, that's also why I'm thinking maybe... I don't know. We'll see. We'll have to figure out better whether we update it, you know, or maybe put a pause to the update or something like that. We'll see. Because it's creating a whole bunch of things right now. Anyway, I'm still not sure why. So we got center, and we're going to offset that by half of what we need to do. Yet it's not properly centered. So that's normalized. So that should be of length 1. We know it's going to be 250. I'm thinking this wrong. I'm thinking this the wrong way around. Thanks for that. Okay, we have to reopen that, of course. There you go. Path. Yeah. Now it's what I expected it to be in the first place. Okay, let's go here. Let's see if I only make it 2. Oh, that's, of course, I'm going to recalculate until I move it. Oh, there we go. Boom. All right. 5, I think, goes pretty good. There we go. Okay. Okay, now we got to do the same thing for height. And that's going to become a lot of boxes for this. We'll see how well it handles it. What's my view setup as? Yeah, that's enough. Near value. So we really make this whole thing way too big, it seems like. I don't know why it's cutting off over there. That makes no sense to me. Oh, because it's ortho... perspective. Thank you. There we go. So yeah, big as asteroid belt like this, which is really not what we want. Top view. Okay. I wonder if we should do some sort of delay in there. I think it's probably a good idea. All right. Okay. We're actually going to change this and just do this. It's good enough because that's always the thing that we're going to call. First chase is not going to send us anything. Yeah, let's do it like that. So, var dirty is true. Okay. We also need to go over here. Yeah, I'm gonna leave that in there for now. I'm gonna add a timer in here. Okay. Wait time, one shot. Very good. Okay. Actually, I'm gonna call this status 0. Oh. 0 is first. 1 is updated. 2 is 30. Okay. All right. So what we're going to be doing here is if status is 30, I think. No, that's what we need to do. Okay, so we are going to do this. Bar is 30 is true. Cool. Then here at the end, I'm going to say 30 is false. We've done our update. Sweet. Cool. Actually, no, we're going to put it at the top. Boom. Boom. All right. Boom. Boom. And what I'm going to do here is add a new method. Curve changed. Boom. Boom. And here we're going to say if it's not dirty, so we've updated it. We're going to say 30 is true. And then we're going to say update timer start. Boom. Cool. And now in our update timer, we're going to say timeout connect to our asteroid files. Boom. And here we're going to say if we're still dirty, so we haven't done this already, update notes. Okay. So now in our test scene, which we probably have to reload again for this to work. Actually, yeah. Okay. All right. That's interesting. I did something slightly wrong. Okay, this one I don't need anymore. Yep. Okay, when we're ready, recording update belt. Okay. Oh, okay, that's why. Okay. I'm not thinking it's true. Because I was going into a different way. Right. Let's redo this. So that means that the first time that we come in here, it builds it. Boom. Definitely need to figure out why we've got these gaps here, but we will. Okay. Where are we? Ah, I need to go there. Path. So now, when we move this, okay, I think 1 second is definitely too long, but at least we don't get lots and lots of updates as we do this. So let's go and move that to, let's do 1/4 of a second. Now, don't know if that reacts right away. That's much better. So that keeps our interface somewhat responsive. All right. All right. Yeah, that makes that a lot better. Cool. And at least make sure that, you know, we're not getting 60 recreates a second as we edit stuff in our interface, because that's my frame rate on my monitor. It now, you know, we get a maximum of 4 updates. Okay. Now, do I need to do something more with an interpolated baked? No. No, that's definitely not what I want. That's it. I guess that's because of the orientation. Well, we're just going to oversize, because again, you know, the little visualization of the box I have done just for visualization. Obviously, the green box is going to disappear. Yeah. Actually, you know what? We're going to call this vector 2. No, I want to leave this the way that it is. Okay. There we go. This one I do want to do like that. Oops. Please. No. Boom. X. No, don't need to do that. I can just do the offset like that. Boom. Sweet. All right. For Y in range. That's all right. All right, plus is center plus y node size. There we go. Cool. And then here we're actually going to use pos instead. Pos. Okay. Now we're getting even more boxes. Woo! And I bet you we need to calculate that, maybe? Yep, thought so. That is a bit of an annoying thing. Always having to reload this. Unless, of course, there's a bug. Why? Oh. Ha ha. Ha ha. Ha ha ha. Yep. Well, we can easily fix it by making that a 3. And we don't have an offset on the Z, so that's good. And the other thing that I'm doing wrong is... no, I do need to do this. No. That's right. So, that's fine. Dot x minus vector 3 dot up times offset y. That might make more sense. Also means that this needs to be vector up times y times node size. Vector 3, please. All right, let's see if that works. It definitely takes a lot longer to update because we're creating a lot more boxes. And this is the thing that I'm worried about, doing this interface-wise. Ooh. Okay. So yeah, we can see that we have a lot of boxes. I'm actually very surprised at how well this is still rendering. Okay. Top view. Wow. Alright, so that is definitely taking way too long to update. I'm surprised by that first reload because it actually didn't update anything. I still don't like that there's so much gaps in between these things, which is kind of interesting as well. So the thing that I'm wondering about, because again, this is where GDScript kind of doesn't have enough oomph, so to speak. And especially when we look at how long this got. So that's always a bit of a problem with this. Now, the other thing that I'm going to change, I think, is that we only recalculate when we let go. But we're definitely having too many boxes for what we're doing here. Okay. So let's do the same. It's loading, it's thinking, it's doing stuff. Okay. All right. This is one way to make it fast. Boom. Yeah, let's just make sure that we are doing this. Actually, let's go. Boom. Remove. Boom. And boom. Okay. So we're gonna have to go and do this. Now in this case, I'm not worried about updating these in our ready function, because as long as this gets called in a ready function, our updates get called. So here all we do is inside tree update belts. Boom. And again, in our update belts, we are already checking if we have a belt path and only updating at that point in time. So I'm happy about that. So obviously we need to do the same here. Set width. Func set width, new width. Width is new width. Oh, haha. Wondering what that thing was. So same thing, if inside tree, update belt. Let's create a function for height as well. That's height. New height. 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 There we go. Get. Boom. There we go. All right. Perfect. Let's go back to this test scene. 3D. That's our belts. Okay, I need to reload it, of course. Okay, we have still got a problem in our script somehow. But not new height. Set height. Oops. There we go. There we go. So back to 5. 5. There we go. We got the boxes. Okay. Alrighty. That's all the boxes. So and they all have our nice little squarey thing in there. That's good. Let's go get rid of this guy. Okay. Now, do we do our randomizing in here? I think we're going to do our randomizing in here. I think that's actually a good idea. All right. Okay. Max instance count. Okay. If that is, I think, an engine. No, I can never find this. I always forget where this is. Editor hint. Engine editor hint. Yeah, why doesn't that autocomplete? It's so annoying. So if engine hint. No, editor hint. So in the editor, we're only going to have 10. In the in normal, we're going to up it quite a bit. So I'm actually going to go and remove that. And we're just going to say instance count. So, and now we're going to go and generate our instances, which also means that we're going to go and define a size here. Our next distance. And I'm going to make it 75. Now, we're doing 100 by 100 as size. Actually, let's go and make that 100. No, 50 then. Sorry, 50. Because, of course, we're going to do this as an extent. So we're going from minus 50 to 50, which is nicely 100 by 100, 100. All right. So, for I in range 0, instance count. There we go. All right. And now we're simply going to go and calculate an origin point at random. So plus vector 3. I think I have to do it like this. Can't remember. What was it? Slash. I always forget. Let's see. So this is going to become hold on. And range minus max distance. Yeah. I'll figure that slash out in a minute. So I just want to have it over here. Boom. An error. Oh, it's just one slash. That's just one slash. That's it. For some reason I have double slash in my head. That's better. Boom. 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 There we go. Okay. Let's have a look at our other asteroid, our original asteroid belt code, which is this one. What did we do here again? So we're using a color for something, and I can't remember what. So we're doing a randomized rotation, and I wonder if that's really that important. I can't remember what we're using the color for anymore. But that said, let's go and copy this. Let's see. Where are we? Add that in here. But we do have a color format as well. Let's actually just copy all that code that we have here. No, this one. And just do exactly the same. There we go. I'm going to throw that over here. But this just becomes I. You know what? Come on. Oh, there we go. Rotation. That's fine. Down here, min scale, max scale. We can put that in. What did we use here? Can we use that? 1. Okay. 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 Save. All right. Now. Boom. Ooh. All right. So calculating that took a little bit of time, but rendering isn't a problem. Now remember, we're made these into boxes instead of something else. So this is probably the easiest thing to generate for it. However, pretty sure this is a lot of boxes. So let's have a look. I don't know. Hard to say. Because I don't know how well it does the thing. Let's just for fun see how well this behaves in inside of VR. And then we're going to start working on the LOD system for this. Alright, so yeah, we don't have any frame rate left. It is definitely way too much for it to render. Yay. Interesting to see that we can really see where the spacing is. It's a shitload of asteroids, huh? Wow. Oh, and remember, in game, we actually upped the number of asteroids quite a lot more than we just had there. Well, this is obviously an asteroid field that is way too dense. It's not bad. Holy crap. Okay. All right. Funny as can be, though. Let's go back to our script. Let's go to here. Let's bring this down to 15. And this down to 5. All right. So each one now has got 5 asteroids in there. They're not very spaced out, though. That's the interesting bit. Doesn't look very random to me as a result. Very interesting. Now the question is that because we're doing something wrong here? So we've got max distance, 50-50. I don't get why it is grouping them so close together. That doesn't make sense to me. Even though we're only adding 5 in the editor mode. I remember having problems with rand range before. Well, let's humor myself for this. Make it 100. And say rand f 5 times distance. Okay. Did that just change scale? Did I type that wrong? It's right there. Oh, and I, okay, it helps if we actually update the right value. So probably everything was working, but I had the wrong... Actually, let's go and undo all this. That's good enough. And now we're going to change our max distance back to 50 and our instance count to 15. There we go. All right. That looks more random. Cool. Okay. That looks far more random. Okay, let's see how that looks in VR then. It's still costing me too much frames. I need to move that frame counter a bit more to the middle. Can't really see it very well. Let's see how populated are. That's a lot of asteroids, even though they're only blocks. Alright. That's definitely too many. Whoa. I like the size of this thing. I don't like that it's actually a square asteroid field. At the end of the whole field. Okay. So it is generating it pretty well. And that's only 15 per thing. I'm actually going to not doing this already. I'm actually going to go, say, generate asteroids. Max distance. Count. Max distance. Min scale. Max scale. There we go. Boom. Take that out. I'm going to call this instance count. There we go. Okay. Alrighty. New node dot generate asteroids. Over here's if engine dot hints. What do we call this? Instance counts. So I need 5 in the editor. Then our maximum distance is node size, but then node size times 0.5, then 1 and 4. Else, we're going to create 15. And actually, I want to make that 25. Okay. Okay. So I actually want to make this bigger. And that's going to be 2 and 2. All right. Okay. Let's see how that runs. Still a horrible frame rate because there's so many of them. I also want these guys to be closer to where we are. And I think I'm surprised by how dense this looks. Because it just looks like there's many more than 25 in one block. Has to be. Has to be. Can I get this at all? Ah! I really hate it when it does that. Okay, so 2, 2, 5. Why? Oh, that's because here. That's a really annoying problem. Okay. Okay. There we go. That's a bit sparser. There we go for 3, 3. Okay. What does that one look like? Bum, 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 bum. Alright, frame rate is definitely coming up but quite a bit. And our asteroid field now looks a little bit more manageable. Okay. Yeah, and this now means that our rocks aren't completely crazily around. Okay. Obviously, we don't have our collision shades back. That's something that we still need to look at. But yeah. On that, we got nice little cubes. Ah. All right. So. Now, one thing that I really wonder, because of what we're doing, if I go in here, and I make this actually 1, 1, and I make that 600, that should give us the same amount of asteroids. No, that's not true, because I didn't up the asteroid count. Yeah, so now we have way less because I need to do the number of asteroids higher. Okay, and that's not something that I'm setting currently, which I need to change. So I'm still going to leave that at 5. But I'm going to say export instance counts. 25, so get set instance count. There we go. Func, boom, new count. Instance count is new count. Boom, Boom. Okay. There we go. Okay. So this was 3 minutes. 9. One, so 200. Okay. Let's see what that does. I might go for 2 by 2. Let's see. And again, one of the things that I also want to do is I don't want to make it this squarish, but okay, but we are on 120 frames per second now. Even though we have a whole asteroid belt here. Again, we're just with the cubes. But at a distance, you don't see that they are cubes. So. Alrighty. So that's the next thing that we need to go and solve. All right. And this one's going to be pretty tricky because of... First of all, because it's so freaking dark. And these are very, very hard to see little boxes. All right. So. Okay. Now here comes the problem, is that we need to figure out where our player is. Where our camera is. Alright. Now, let's do left. Just make that one. Okay. Link process delta time left minus delta. If time left smaller than 0, time left is all right. I'm gonna randomize how often we update this. Actually, probably want to do this between 3 and 1. Because I don't want everyone to update exactly at the same time, because then we're going to get a lot of processing all going at once. Now, it's even going to be interesting to see. No, I actually don't want this over here. I actually don't want that over here. So, we're going to have a func check LD. We're going to do it like this. We're actually going to move this over here. Boom. And that means that our time left what we're now going to do is for child in nodes. Oh, it's because we're not in the right one. Nodes dot get children child dot check LOD, and we need a camera position there. do that over here. Is we do it like this? I don't think we can do it like this because we're gonna need to set that. Yep. Actually, I'm gonna rename this to player position. There we go. And we're gonna put here an export node path player node. Oops. Come on. We want that over here. Okay. Player. Get node player node. Boom. You know what? I'm gonna do it slightly differently. I'm gonna move this over here. If player node. Boom. Set process. If you don't have a player node, boom, stop doing that. Okay. Then here, if player. Actually, no. If we have a player paths is player dot global transform dot origin. Boom. Okay. And that means we now can send our player paths through here. We can actually put that in already. Where are we? Ready? If engine editor hints set process. So we don't want to do that in our editor. No point, because we don't know what the camera is that's being used. So not really a way that we can do that. But this should now allow us in our test scene to say our player is going to be our plane. Boom. Okay. That's all good. So as we get closer, we can do calculations with that. All right, cool. So now we need to start doing calculations. And what we're going to do here is var distance is player pulse minus global transform dot origin. So the origin point of our multi-mesh. Okay. No. Yeah, not 0. Gonna get 1. That's not good. 1. It's also gonna be 1. 2 is let's make that 100. All right. So if distance bigger than distance lot 2, so we're further away than where we want to be for lot 2. Now in theory, it shouldn't matter how often we update that. So if it's bigger than 1, 2. If it's bigger than 0, go for 1. Else, we're going to do our lot 0. So because I've put the first two on 1, we're basically switching between 3 and 2. 3 if it's very far away. 2 if we're getting close enough. All right. And that's only 100, so that's pretty close where we should see the switch. Way too close than what we want. And this is the problem that we have with the lot logic. Why? Non-existent function, editor hint in engine. Because it's not a function, it's a property. Yeah. I could use OpenSimplex to do that, but for something like this, a simple random function is more than enough. I really have to fix that if I'm inside the ship, the shield is not on. Okay, so now the problem is because these guys are really dark, it's going to be really hard to see if they are actually switching. Well, they still look like boxes. I think we almost need to be right on top of them before they switch, because we need to be 100 away from the center. So any switch that we want should be more than 100 probably. Unless it doesn't work. That's also possible. Well, I don't know. They're still all blocks. So our logic is not working. Aha. I wonder why. Okay. Cool. Okay. There you go. Got a player. Okay. Get our player position. Very good. Second. Pretty far away. That makes sense. We're checking whether that's 100. 1. Yeah, that should go well. So we should at some point get there. Okay. Continue. Really? Okay. So that's definitely updating. Cool. I'm just gonna play on my screen for a sec. Let's see if we hit a breakpoint when we get close enough. Oh, hold on. We made it 100. And then now, okay. So, we're definitely getting there at some point. But, okay. So, it is working, but my problem is we've made this a lot bigger. 600 is the size of this. So, actually, I want to go and make this 300. I want to make this 100. Make this 2. I want to make this 2. Boom. Let's see, even though that's a little bit more, that's going to be a problem. So, actually at 300, I want to then get the maximum detail in. But for now, I'm going to make this one 300. Okay. And let's see if we can see it switch now. All right. All right. Increasing the number of multi-meshes has had a pretty significant effect on our frame rate. So, and again, you know, most of these are so far away you can't even see them. So that's going to be interesting as well. I think we're going to even have we're going to hide the thing when we get far enough to something. So there we go. Boom. All right. Yeah, you see that nice switch there? That was pretty interesting. All right. Okay. So 600 is probably a good point for our highest level detail. So I'm actually going to make, oh, sorry, 300. I'm going to make that 300. I'm going to make that 600. I'm going to make this 1200. And I'm going to go and make this 24. I'm going to add that one in. 3. And it's going to be multi-mesh. Visible is false. I think it's actually probably a better idea to do it then like this. And here, say, we're going to show. Let's see what that does for our... Because one of the things that I also still want to do is that if the asteroids get too far away, we fade them out. So we already see now that we don't have any asteroids because they're too far away. At some point, we should start seeing some. There we go. So they pop into existence. I think that pop into existence far away thing needs to be closer. There already are higher level details. All right. That's not bad, actually. Now, again, we don't have any collision state shapes anymore. That's something I need to look into, and I think that's going to have an adverse effect on our performance. So this is when we see almost all the asteroids. Pretty neat, though. All right. I'm not even sure if we need this many LOD levels. I think I'm going to make this a bit more. And I think here I bring that down to 75. And what I want to do is I want to make this go way closer. Okay. Yeah. Yeah, I'll need to figure out a fade out for the asteroids when they get too far away. That's definitely something to work on. Alright. Let's see how much difference it is when they're a lot closer. Because I am definitely not happy about how much performance these asteroids start taking when they're all on screen. Because we're only pulling about 80 frames per second right now. Alright, so one way that we can make it look fuller is actually getting the size up. That's already in there, so I want to put that over here. So, scale. Set minimum scale. Yep. Yeah. Cool. Oh, it definitely makes them easier to see. You also still really easily see that they're blocks now, so we definitely need to put our minimum scale up. I do like this larger scale. It does make the whole asteroid field look a lot more there. Okay, cool. But I also think that that's a good excuse to lower this to 50. And now for this. It goes there. 24. Maybe like this. Let's see how well that works. So actually kind of makes sense that we put on the highest level of detail before we even close. So we can see that the asteroid field at the end kind of disappears. It's kind of interesting. Also looks like there was kind of like an overlap there. Not sure what that was about. I am still surprised at how much frame rate this eats. Mind you, maybe that highest level of detail isn't really needed. Let's first see if we're actually still seeing any that look like squares, because we can see that those ones all the way at the back, I recognize them to be blocks. So that's pretty cool. But I think a closer level of details can be less aggressive. And I'm even wondering if we want that 0 one. So I'm going to make this 6. I'm going to make this 3. I'm actually going to make that. I'll go for 5. Yeah, let's try something like that. And again, it's just a lot of trying out and seeing where to go. I definitely want to make sure. Yeah, I think I want to have the. Well, that's doing pretty well performance-wise. So we're getting. Yeah, if you're getting in the thick of this, it starts dropping a bit, but it's not too bad. I also still think that this is an awful lot of asteroids very close to each other. Whoa. So yeah, I'm wondering if we need that final LOD, to be honest. That's not bad performance-wise, actually. Because I have a feeling that the highest LOD, we're not even getting close enough to these asteroids to really figure that out. All right. And you know what? I'm going to make it 0, so that actually doesn't count anymore. Down on 500. All right. One more thing that I want to do here. All right. Okay. Asteroid shader. Okay. Let's start with that. All right. So here I'm going to add a distance fade into it. Oh. All right. What's the thing called? Model view. So, by taking the origin point in our model view matrix, which is our world position combined with our inverse camera, we actually get the position of our asteroid relative to the player. And that means hey, Drinsoft. Going well so far. We're getting pretty close to making this work the way that I want. So, what we're going to do here is we're going to set a uniform float. Min distance is let's say that was at 3500 that we have in here. So that's going to be, because we're going to have one more level behind this. Float. And then we're going to have it faded out. Yeah, let's say by 4000. And that's going to be over here, our number 4. We're actually going to hide it at that point. And again, we want this to be a very small bandwidth we're going to do, because we want to avoid applying alpha to a whole lot of these guys, because that is all of a sudden where the calculation becomes expensive, or the rendering becomes expensive. Okay. Minimum distance, maximum distance, that's all good. All right. There we go. Here's one. All right. Varying, it's called. Okay. And that means that we're going to have that in here. Alpha. Boom. So this one is going to support transparency. We don't have anything extra in there. Very good. So now our alpha calculation is going to become min distance There's no auto completion in there. That's right. Divided by max distance minus min distance. And that's going to be 1.0 minus that whole calculation. Okay. Where did we forget one? Oh, yeah, that doesn't need a default value. There we go. So we're calculating our alpha here. Because we're using our model view matrix, all our vertices should be getting the same value. That's the important bit here. All right. Duplicates. Fade. So we're going to make a duplicate of our material. Okay. But we're going to go say load. Themes, misc, fade. There we go. Perfect. Why do we not have those set? Actually, seeing these are really far away, I think there is absolutely no point in having a normal texture and that one. Which also means that we don't care anything about our normal or bitangents. We don't need to calculate that one. We're not going to do that. We're not going to do that. Put that to 0. Up to 1. I'll take that out. Don't need any of those calculations. Don't need any of that. So we purely do our distance fade out. All right. That should make that a lot easier. All right. So if we now have a look at our asteroid mesh 0, there you go. That's spinning. Now we have the right material being used there. Cool. Sweet. All right. All right. Here we also have our lot 3. We're going to duplicate that into a lot 4, which is still going to be our beautiful box. There we go. But now we're going to go and load in our fade version of our mesh. Perfect. Which now means that we can go and add that one in. And again, you know, probably the lot 1 we don't really need. 4. There we go. That becomes 4. That becomes 3. 3. And that becomes 4. So now the furthest ones away are going to have that fade effect. And then we're going to have just normal boxes for a little while. And then we're going to have our actual our actual asteroid. All right. So here we go. All right. I was expecting there to be more things coming into play here. It's interesting. All right. Problem is that if we're flying this way, there's too much darkness. Can't really see our asteroids at all. So I want to go this way. All right. So we see our asteroids fading in. I want to be even further away. I'm wondering if our distances aren't wrong. Okay. Okay. I think our pop-in distance needs to be a bit better. Actually, that means that this one needs to be closer by. And this one needs to be a bit further. Okay. That should be like this. No, we can keep that at 35. I think that's fine. Okay, so how is our camera set up? I'm wondering if I'm not going too far with these. Here we go. No, that's in our construct. Not main. Oh, yeah. Much further. Okay. I'm wondering. No. There we go. Just wanted to create a little bit more distance so we could see that fade better. Let's see if that works now. It's going to be more, well, it's more inspired by games like Wing Commander and Star Lancer. Whoa, I can hear the enemy fighters firing at me. That's interesting. Anyway, get out of here. So yeah, now we can slowly see our asteroids fading in. That's already the end of the asteroid belt. Now, again, I need to add something in that the belt doesn't end so spontaneously. Oh, I'm half outside of my craft. Okay. Yeah, that's kind of cool. Mm-hmm. Yeah, not too bad. All right. Like that. A little bit bigger. Okay. Just want to see them a little bit further away. Um, The annoying thing is that, of course, I need to go and set this one up properly. There we go. 55, actually. Let's have a look. Yeah, we're doing all this work for a asteroid field that is very hard to see when you're looking at the darker side of our environment. I kind of want to strike a good balance that it looks nice and it still performs. All right. I think at this distance, we can actually make our asteroid belt way larger. And because now we're not rendering that many asteroids in editor mode, we can actually really nicely get our path going. There we go. Yeah, pretty cool. Let's look how that looks in game. The sky is an HDRI. So it's a fixed image. And I really need to figure out why my controller is drifting. Alright. There you go. Yeah, this looks really nice. It really fades the asteroids in very nicely. Alright. So, one more thing that I want to try. Just to humor me, is I'm going to go and change that to 4, change that to 2, so we're going to get a lot more. Then we need a quarter of these, so this is 50. Let's say that we do 10. In theory, we should have the same amount of oh, dang. No, I forgot one more thing. I need to make this smaller. So let's put that back to 200. Not exact, but close enough. And it probably should have... I just want to do that, see what that does to performance. That's still going nicely at 120. Okay. Going a little down, but not too bad. The reason I'm trying this is I don't like the multi-meshes to be so big. As in, you know, how much space they do. Yeah, that's pretty cool. That works pretty well. Yeah, now it starts struggling because it has to render quite a large part of the asteroid belt when we're looking this way. Interesting. Okay, try one more thing. I actually want to make this a little bigger. Oh, no, it's so good. I want to make sure that I'm not in the wrong scene, because if you are still in the 3D scene in Godot itself, well, I see one frame where they're not all hidden, which is also worth doing something with. So because I made them bigger, and while it spaces stuff out a little bit more, we have fewer multi-meshes in total. It seems to be working pretty well, pretty decently. Yeah. I am relatively happy about this. Now it goes a little bit down to 90 when we're in the middle of the whole thing. Can't really see it too well, how much is dropping. Obviously, we've got a ship in there as well, so I don't know how much difference that makes. Quite a bit. So it could actually be our ship that is causing some of the resetting the screen. Some of the frame rate drop, which is fine because we still need a better ship. This is a too high detailed one for what we're doing. But all in all, we have a an LOD system going. Again, I don't know why this guy keeps all right. Yeah, you're out there now. I don't know why he keeps getting stuck there. It's so funny. Oh, he's trying to attack me now. That's a good thing, I guess. Anyway, let him fly around. B. Yeah, all in all, I'm pretty happy about this. All right. There we go. Ooh, it's nearly 2 a.m. So I think that is more than enough playing around with this. I think the solution that we came up with for asteroids is way better than what we had before. Now, I do think I'll make this even bigger. Really make them spare out a bit. Okay. Now, I've got no idea how many asteroids we ended up with. I do think that I need to tweak the numbers a lot more and play around with the actual LOD positions. I have a feeling that there's more optimization to be had there, so that's definitely something worth playing with. But to throw a nice asteroid belt into a level by just putting a curve in there, having it create all the elements that we need, in a pretty decent speed as well. It doesn't seem to be, creating a whole bunch of overhead to do this. I would like to do more shapes so that the asteroid belt doesn't seem like a square. And we need to put our collisions back. Although in there lies a question how much I really want to do with that, but I'm not sure yet. Scale some of those up a bit as well. So yeah, in our preview, they're all boxes, which is fine. Happy about that. That just makes it fast in the editor. It's all good. And then when we run, we actually have multiple LEDs. Now, we support that final LED, this one, even though we're not really using that because we've got that set to 0. I think this one can probably be a bit more further. Yeah, I'm happy. So, I hope you guys enjoyed this. This is one way to address a LOD system. Now, in this case, we are doing this with a multi-mesh, but that's only because I want to create a whole bunch of these things. Now, if you have simpler objects and you just want to say that you have a city and you have buildings, and you just want the building to be, a simpler building if it's far away, this same approach with doing something like this and then doing something like this by changing them over, or even just having the meshes in there and just hiding and showing the right one, works fine. The clue, and again, I have moved that into here. The clue is to not try and calculate that every frame. Especially if you have hundreds and hundreds of objects that you want to do an LOD check on. Doing that every frame will just cost a lot of performance. But like over here, where I'm now doing it once every couple of frames, or anywhere between 0.3 and 1. And I think this actually doesn't make sense anymore to do it random like this. I think we can easily just change that back to 1, which I think it was over here as well. So basically every second we're checking our LOD. You might bring that down a little bit and maybe say every half second. But it's more than enough. Again, this depends a bit on what sort of game you have. And how far your player can travel. The other option here is to actually do it based on that. How far has your player traveled? And you say, I'm going to update the LODs of all my objects if my player has moved more than a meter or 2 meters, or in my case in space where we're doing much larger areas, we have to maybe fly 100 meters before we update our LODs, because if the player is standing still, there's no point in checking LODs and switching. So that is definitely room for improvement, but also definitely the sort of thing that you want to do here. And again, we might do that next time and do a little bit more with LODs, and looking at our enemies. Now, I don't have different LOD versions of my my different models, so maybe that's something that we come back to once I do. Because again, the plan eventually is to have some ships designed for this game, and then I can talk to an artist and I can ask the artist to create lower level detail versions of each ship, and those are they're perfect to do in the same way. And then you get the situation. Let's go and file system. Actually, let's just go through here. And then here. So here we just have the one, where are you? The one mesh. And we would just have a mesh LOD0, mesh LOD1, mesh LOD2, or, you know, whatever format that is in. And we're just showing one. We're not showing them all, we're just showing one. Which, by the way, reminds me that I want to go and... No, we need to do that in here. Because if we're in... No, engine. We're going to start off hidden in this case, because right now we see the one frame, we see them, and then they disappear. So that was something I want to do. But anyway, so yeah, so in the case, like for instance for this, we would have, you know, an LD 0, 1, and 2. That, with something like a fighter, we probably have enough about 2 meshes. You know, one is this one, which is the one that you see when you're up close, and really once it's that far away, we can already switch to a much simpler model, you know, that doesn't have any of the detail. So you can see there's an incredible amount of detail in here. We can see the cockpit. So that's quite a complex mesh. Well, really, the moment that you're over here, that detail is lost, right? It's just lost. So you don't see it any closer. And then even when you go like this, you know, it could actually be, you know, a textured box or something like that. You know, while in this case, I don't think there's going to be a lot of performance gain for a game like this, where we might have, you know, 10 enemies at a time. It's still worth investigating. We'll see. You know, it's the type of thing that we need to start looking at. All in all, I think this was a very successful night. Went on way too long. So, hi, Stefan. Sorry, you're joining just about as I'm closing off, because it is nearly 2 a.m. for me. We're actually 2 hours over time for this this stream. But yeah, we have a simple LOD system for our asteroids. Well, maybe not even that simple. And yeah, like I said, I need to tweak the distances. I need to tweak those things. But all in all, I'm pretty happy with how far we've gotten with it. We also have, you know, the indicators to get an idea of where our enemy fighters are up to. So it's easier to chase them, easier to fight them. So that's pretty cool. So yeah, we're getting more and more of this logic ready. Not sure yet what we're going to do next week. We might continue with some more level design elements for this. I really need to start getting some thoughts together about how I'm actually going to put a mission together, so that you actually have, you know, events being scheduled and stuff like that. That's something that I want to start thinking about. So yeah, please join me again next week. Hope you guys enjoyed it. Yeah, have a really, really good Friday, or a really, really good weekend, depending on where in the world you are and what time it is for you. Till next time, thanks for joining.